Professor K. Pandey, Principal, SBS Government Degree College. Professor, Principal, RAAT Government Degree College, Kashipur. Asif Prophet, Principal, HNB Government College, Hadima, and Dr. B.D. Upadhyay, Principal, Dham Jyoti College, Aligarh. Expected only chairs of this virtual conference, Professor Mangala Joshi, Department of Textile and Engineering Fabric, IIT Delhi, Vivek Kumar, Professor, IIT Delhi, Professor Taneja, Head of Department, Dr. Ambedkar University, Agra, Professor Mukesh Singh, Director UPTTI, and Dr. O.P. Nautyal, Scientist, User, Dehradun, Uttarakhand, and Dr. M.C. Vashne, Associate Professor, Sri Vashne College, Aligarh. Conference Chair, Conference Co-Chair, Conveners, Co-Conveners, and Organizing Secretary, students and student coordinators, advisor committee members, student committee members, and technical committee members, and all the dignitaries and delegates, different and eminent speaker, distinguished guests, and participants, everyone present in this conference. On the behalf of entire SB family, CDMR, USR, RH and HNB colleges, and on behalf, I take this privilege to heartily welcome all the field, delighted by your presence. Thank you for joining us in the virtual conference on recent advanced analytical techniques 2020. I once again extend you a very warm welcome So I would like to invite our patent chief, Professor Bhuvnesh Gupta, to bless us. Please welcome Bhuvnesh Gupta. Please, sir. Please, sir. Say something.
Can you see me? Hello? Hello?
Hello.
Can you see me?
Sir, please.
I don't see myself there. Hello? I don't see myself. My video, hello, I don't see myself there.
You are seen, sir.
Okay,
You are indeed seen. Yes, please go ahead. Yes.
Okay, thank you. Yeah, so good morning to everyone. And this is a very special occasion that I can see in this corona. 19 problems, at least some scientific and technological things are happening. So my sincere appreciation to all the people, all the organizers, especially I could see how Shiv Upadhyay team took so much pain in organizing this event. The second event being organized by Shiv Upadhyay. And so that shows the creativity of this person. I'm sure that he's a rising star and going to do a lot of good things for our science. Another thing which which is important also for all of us is that this event is being organized as the joint event where the Sanjay G Medical College is there, or this what is that, HN Bahuguna G College from Khatima is there, DST Uttarakhand is there, Srivashne College Aligarh together makes a beautiful event, because in today's world it's very important that you work together with hand in hand. Single person, single institution cannot do too much. But if you are together, I tell you, the message goes much.
अब मुझे फाइल वगैरह शेयर करनी होगी.
Okay, so this is how I appreciate the whole thing which is happening, and at the same time, what is important is that
ऑफ कर देता हूं, फिर मैं आशीष से बात करता हूं,
platform.
ओके, मुझे प्रेजेंट
the platform that we are putting in, this platform is very important platform where people from different parts of this country are joined together, especially in this conference, which is RAAT 2020. Now, this RAAT 2020 is really important. It's important in the sense that whenever you are working on any material development, so this material development involves too many things together. It involves chemists, it involves physicists, it involves biotechnologists, and so many people are there together. So once you develop a material out of so much effort in there, what happens is that you have to characterize it. You have to find out what is the real structure, what is the real performance of this material. This is where the analysis of the material is important. And this analysis needs proper, I would say, management of the systems, proper information about the systems, and how to use them. So there are many new things each time coming out. You know, each year you'll find something, some new is coming, some new features are coming, and these features really help all of us to see what additional information we can get from these. So this event, which is RAAT 2020, is really very important as far as today's world is concerned. What I realize is that the speakers are from different institutions. And this is, again, something like credit going to the organizers, which have taken up this task. People from IITs are there, people from CSIR labs are there, from DST institutions are there. So it's a galaxy of the people who are going to be there taking part in giving talks. And we really find this kind of situation when all the stalwarts are there. And this is the nice opportunity for all of us to look at these things, look at their work, and see how we can also synchronize our activities. So I would like to say that with this much in there, it's very obvious that out of these 2 days seminar or conference, whatever you call it, we are going to have many more new things out of all these interactions with the speakers. And I'm sure you are going to utilize this knowledge, this information to your subsequent development of your research groups, your students, and your technological output. So with this, I'd like to welcome all of you, all the delegates from different places, that you could take out time to join this event. And I wish that today's program is going to be very beneficial, very useful, very informative for all of us. So thank you so much, and I look forward for a very fruitful time ahead. Thank you.
Hello. Om Upadhyaya.
Yes, yes.
Okay. Uh, Thank you, sir, for your valuable inaugural address for this our virtual conference on RAAT 2020. Uh, Professor Bhuvnesh Gupta is the professor of textiles and IT. He did his PhD from IIT Delhi and spent 8 years in France, Sweden, Switzerland under different capacities. He research career in field of polymer functionalization, biomaterials, and tissue engineering. This work is being carried out in the collaboration with University of Uppsala, Sweden, and in some Paris, France. At this national level, the University of Chandigarh, Nehu, Shillong, and Sikkim Manipal Medical College, Gangtok. He did his brief assignment as Director Research in SMU and had interesting he has been awarded medals at the university level and has been granted visiting fellowship in different European countries. He has been the member of DBT Talks of Government of India. He is the president of Asian Polymer Association, Society of Tissue Engineering and Regenerative Medicine India, Society of Biomaterials and Artificial Organs, and Indo-Italic Forum on Tissue Engineering, along with several other national and international societies. Dr. Gupta is in one of the editorial board, several journals, and is on the panel for several universities. He has about 200 publications in international journals and more than 400 conferences presentations in India and abroad, along with 30 patents to his credit. He has authored 8 books published by international publishers and has been invited by several laboratories across Europe and delivered talks. Yes, he is the president now currently president of Asian Polymer Association, Society of Biomaterials and Artificial Organ India, and Society for Tissue Engineering and Regenerative Medicine India. Sir, thank you so much. Thank you very much, sir, for your very kind and nice words and inaugural address, sir. You are the encyclopedia of knowledge, and we are very fortunate to listen from you. Thank you for your valuable ideas on the subject. Now, in this line, I would like to invite our next patron in chief, Professor Durgesh Pant, for the conference inaugural address. Professor Pant is the director of USERC. He is among the earliest adopter and pioneer of computer science and information technology in this part of country, having established the Department of Computer Science in Kumayu University as early as 1980, 1989-90. For almost 30 years, he has been avid promoter of computer science and technology, especially ICT enhanced education. Sir, welcome you, sir, for your valuable inaugural address. I invite you, sir. Please continue. Please.
Good morning to you all. Good morning, Shiv, and it has been truly fantastic, and for very, very kind words you used. And I'm a lifelong learner. And it is again an I could hear men like Professor Bhuvnesh Gupta, and what an encyclopedia and what a reservoir of knowledge he is. So it is fantastic. It is fabulous. I'm just because in my capacity of being the director of this Uttarakhand Science Education Research Center, because I get to know many a times. I'm fortunate that so many streams of sciences, they finally merge into becoming this beautiful set of knowledge. So I always cherish and I always relish that. Thank you so much. And the chief guest, the very eminent Vice Chancellor, Professor Ashok Mittal of Dr. Bhimrao Ambedkar University, Agra. And as you could see, this MIET, that's very important premier institution, especially in Uttarakhand, and Professor B.S. Bistaji, who is a very renowned academician. And there he is, Dr. Bhunesh Gupta, Dr. K.K. Pandey. I could see Professor Chitra Pandey. Namaskar to you all, to everyone, Professor Vashne and Dr. Professor Chandra and Ashok ji, RC, because Purohit ji, VD Upadhyay ji, Shiv, and all Galaxy, there are n number of people. And very quickly, Professor Gupta said it is a kind of a, that kind of a grand alliance and collaboration, which is so very helpful. And the things don't happen in silos. Now we know for certain these days. And CERN is the prime example. And CERN, recently they again came up with so many subatomic particles. So it's still the voyage, the journey, and to know this quest is on and this journey is going on. Maybe physics, maybe chemistry, maybe biology, maybe any other, any other discipline, any other field of knowledge. So similarly, CERN happens to be collaborative effort from scientists from all around Earth, from this beautiful planet. They come together, they deliberate, they discuss, and they find out this, the basic understanding to know this beautiful Mother Nature. This is what the basic science is. So similarly, this collaborative effort, wherein so many institutions of of eminence, of prominence, and of significance, they have come together. They are deliberating. It is something fantastic. I truly salute. And from my side, from USAC side, because there are other scientists, everybody. So again, this thing, as Professor Gupta was saying, this will go a long way. And I trust in about a month's time, this happens to be second time around. So we are there. See, 2-3 things, because Dr. K.K. Pandey, if he's around, we always we talk about this beautiful journey of this beautiful universe. We are about 13. To chemistry, my connection has been there's this beautiful universe that came into existence because matter, energy, time, space, all these things came into being, and what is known as Big Bang. In computers, we call it at times Big Bang. So the story of these fundamental features, as Harari says in Homo sapiens, is that there's this beautiful thing, all these things known as physics. But about 300,000, that is about years after their appearance, matter and energy somehow started to coalesce. And to coalesce, becoming into complex structures, and these days we call them atoms, and finally these ones then combining into becoming molecules. So this beautiful story of atoms, this is some efficient. These atoms, these molecules, and their somehow interaction. This we now we say this is chemistry. This can be between these elements, and about 118 elements out of naturally, and then these ones which have been formed after that. So this quest is still on. This chemistry will go on, and we know this beautiful thing that this beautiful planet got created, which is presently infected by and impacted by COVID. So it was again some 4.5 billion years. So how fantastic is this scientific journey we can see? And about 3.8 billion years, as we say, and this billion seems to be so small now. And certain molecules, and they formed some intricate structures, and these are known as organisms, as we know. And finally, life started flowing, and therefore we are there. And the Homo sapiens and this cognitive revolution, as we say, about 200,000 or 70,000 years, and here we are, this known history of about 5,000 years. And this analysis, this kind of modern chemistry, these sciences, maybe ancient Indian wisdom was there. We knew about chemistry, we know metallurgy, we know about all these beautiful things. It was there, and this modern one, this especially Western science, we know for certain about 400 or 500 years of this thing in which magnificent work took place around the world, and all this analytical chemistry and this, so all instrumentation, everything happened. So this is something fantastic that today and tomorrow we will be deliberating. There are wonderful and luminaries, those who will be dispensing, those who will be putting forward their ideas. So that this is going to be something fantastic. From my side, because I always during this COVID times, as Professor Bhunesh Gupta was saying, we have been intrigued by this beautiful this technology. We were never prepared for this, and it came to us kind of an emergency situation. It was, and somehow we adapted this situation with and using this and leveraging technologies. That's why we are sitting in different parts. And at this hour, we are, we are talking about this lovely topic. So, but computers, especially AI, machine learning, because as I'm saying, there's animators, simulators, labs, hands-on can't be done. We know for certain, yes, fantastic simulators are there, animators are there, virtual reality based systems are there, augmented reality based systems are there, artificially induced systems are there. So many things are there. Possibly, we know about chromatography, we know about electrophoresis, so many things. I mean, analysis part, because but how computing these things, because modern, I haven't, I don't know much about it, but what I can see, I can feel that technologies, and especially these neuro-based and machine learning-based technology, can do wonders, especially in chemistry must be doing, because there are so many experts, they would be knowing much, much what little do I know. So this is something fantastic. This is absolutely super, and the way that it has been organized. Looking forward to having very nice deliberations. And I have been. I was asked by Dr. Shiv and Dr. Ashish, and they told me to come over. I told them, I know nothing about this topic, but they said you got to be there. So thank you so much for also giving me this opportunity to put my views. But the journey is on. The new education policy that we talk about, again, it talks about involving all the collaborations. This all beautiful things have been incorporated. So this is high time that we also applaud this wonderful effort, because the science and understanding of science through collaboration, through putting all those different brains together, and to make this India a real scientific power. And I extend my big thank you to all of you, and I welcome all the participants, all the magnificent and very, very eminent people, those who have joined this event. Thank you so much. Thank you so much.
Thank you very much, sir. Thank you very much. The talk was highly motivated, and it's an honor for all of us from you. Thank you very much for your valuable address and ideas on the subject, sir. Thank you. Thank you so much.
Thank you.
Now, I would like to invite Professor Ashok Mittal, which is our chief guest for our event, Vice Chancellor Dr. Bhimrao Ambedkar University, Agra, Uttar Pradesh. Professor Ashok Mittal currently serves as a Vice Chancellor Dr. Bhimrao Ambedkar University, Agra, Uttar Pradesh. Professor Mittal has a vast teaching experience of 43 years for both undergraduate and postgraduate classes. His research interest lies in the area of macroeconomics, public finance, and econometrics. He has also guided many PhD and MPhil as well as postdoctoral fellows. He had served as chairman Department of Economics, AMU Aligarh for 2003, 2006 and 2009 to 2012. He was also the member of Academic Council AMU Aligarh for 2003, 2006 and 2009 to 2012. He was also the visiting professor of National Law Institute, University, Bhopal, and visiting fellow at Institute of Social and Economic in ICEC, Bangalore in the year 2000 and 1994, respectively. He has contributed a lot in the field of research and published a large number of research articles in various national and international journals. He was the recipient of various medals, fellowships, and awards like Teacher Research Fellowship, UGC, National Scholarship for Higher Studies, Government of India, Shiv Narayan Asthma Medical, Garfield William Prize, R.P. Malik Memorial Prize, etc. He is the life member of various associations like Indian Economic Association, the Indian Economic Society, the Jodhana Institute of Economic Research, Bharatiya Arthik Shodh Sansthan, Allahabad, and Uttar Pradesh Uttarakhand Economic Association. He is also the executive president UPUEA 2014 to till date. He also served as vice president Pradesh Uttarakhand Economic Association for 2007 to 2010 and 2010 to 2013. He was also the member of UGC Curriculum Committee in Economic. Respected Sir, Vice Chancellor Sir, Professor Ashok Mittal Sir, please. Are you available, sir? I think there is some network issue. After time, we will connect with our chief guest, sir. So now I would like to invite our pattern series, Dr. Pankaj Kumar Vasne, who has been working as the principal at Sri Vasne College, Aligarh, Dr. Bhimrao Ambedkar University, Agra, Uttar Pradesh, since 2017. He has done his graduation, post-graduation, and Doctor of Philosophy from Agra University, Uttar Pradesh. He is one of the youngest principal working at Sri Vasnia College, Aligarh. He has contributed a lot in the field of research and development at national level. He has supervised 17 PhD students and has about 25 publications in both national and international journals. He has authored 5 books published by both national and international journals. He has also served as Joint Secretary in Agra University Teachers Association, that is ATA, for 2009 to 11. He was also the recipient of Best Principal Award. He is a very dynamic personality and always work hard for the betterment of the education system. He is always very active, visionary, and enthusiastic, and has a firm belief in doing the things rather than saying it. We welcome you, sir. You are your valuable address and principal, sir. Are you available, sir? Are you available, sir? ओम जी सर को देखिए हैं क्या डॉक्टर पंकज कुमार वासनी
नहीं सर, वो कनेक्ट नहीं है अभी।
कनेक्ट नहीं है।
जी।
Now I would like to invite CA Atul Kumar Gupta, Secretary Management Committee, Sri Vasne College, Aligarh, Uttar Pradesh. He is currently the Secretary of Management Committee of Sri Vasne College, Aligarh. He is also the alumni of this college and highly motivated and supportive towards the opening of some new events. Mr. Gupta has done Bachelor of Commerce from Srivasne College, Aligarh, and also worked as Chartered Accountant. He is also the financial advisor of DPS Aligarh, Pavna Group of Industries Aligarh, Mangalayatan University Aligarh, and Murli Krishna Group ETA. He was also the ex-president and secretary at Central India Regional Council of Institute of Chartered Accountants of India, Aligarh. He is also the member of a Chartered Account Association and Hira Lal Barashani Inter College, Aligarh. He was also member of very advisory boards in national and international conferences. He is always a very enthusiastic towards the growth and development of the college. He is a person who always looks for the holistic development of the college and wants to raise the education standard within the college. We welcome you, sir, your valuable address. Sir. Are you available, sir? Are you available, sir? ओम जी आप एक बार देखिए सर का। ओम जी आप सुन पा रहे हैं मुझको?
हेलो।
ओम जी सुन पा रहे हैं मुझे?
जी शायद वो कनेक्ट नहीं है अभी।
अब दूसरे उसमें अटेंडीज वाले में तो नहीं है कहीं?
सब पैनलिस्ट
प्रिंसिपल सर और दोनों पंकज कुमार वासने एंड सीए अतुल कुमार गुप्ता जी।
जी।
उपाध्याय जी उनको एक बार फोन कर लीजिए, और जो हमारे पैनलिस्ट इसमें बहुत से पैनलिस्ट हैं और आप उनको इनवाइट कर सकते हैं। देख लीजिए आपके पार्टिसिपेंट वाली और पैनलिस्ट की लिस्ट सामने है।
जी 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 सर, जी सर, जी सर, जी सर।
आप देख लीजिए ना, पार्टिसिपेंट्स वाला देखिए इसमें जो
Now next in this series, I would like to invite Professor K. Pandey to address the audience. He is the principal of SBS Government PG College, Rudra, Uttarakhand. Professor Pandey already had been the registrar of Kumaon University. He has been the former deputy director, higher education, Uttarakhand. We welcome you, sir, for your blessings. Are you available? Are you available, sir?
ये ये पहले ये पहले देख लीजिए आप कि इसमें है ना, तब आप देख करके तब प्रोड्यूस करिए। हो सकता है वो बाद में जुड़े या नहीं जुड़ पा रहे हो, तो जैसे इसमें नहीं उनका दिख रहा है।
Now I would like to invite Dr. B.D. Upadhyay to address the audience. He is the principal of Dharamjyoti Degree College, Aligarh, Uttar Pradesh. He has an experience almost 25 years of teaching. He has completed UG and PG from Dr. Bhimrao Ambedkar University, Agra, and PhD from Agra University. We welcome you, sir, for your blessings.
Respected guest sir, Professor Ashok Mittal, Vice Chancellor Dr. V.R. Ambedkar, Agra, and Patron in Chief, Patrons, Honorary Chairpersons, Conference Chairpersons, and Conference Co-Chairpersons, Conveners and Co-Conveners, Organizing Secretaries, and Coordinators. I want to express my gratitude for the invitation that I received to become part of National Virtual Conference RAAT 2020. I congratulate and wish all the best for the high level of the organization and the professionalism which made it possible to gather so many different experts and develop on the hello and develop on the activity with success. I admire and also congratulate entire organizing team for holding this virtual conference and giving a message to the educational society that despite pandemic situation of COVID-19 throughout the world, efforts are continuously increase of knowledge by sharing the learned and visionary national platform. I believe that everyone attending this conference will be benefited on the issues related to it. I also wish all the best for the national virtual conferences, recent advances in analytical techniques 2020, in short, RAAT 2020, and believe that the participants of the conference will definitely be with words of the wisdom shared during this virtual conference. Wishing a great success and thanking again whole team of organizers for organizing such a national conferences. Thank you so much. Good morning, all of you.
Thank you so much, sir, for your valuable address. I think with our secretary, sir, C.A. Kumar Gupta, sir. Are you available, sir? Mike, sir, please unmute yourself. ओम जी सर को अनम्यूट कर दीजिए जी यू वेलकम सर वेलकम सर
Am I audible?
या सर या
So, very good morning, everyone, and thanks for joining this mega event. Hello. Hello.
Sir, continue your address, please, sir.
I, on behalf of my college, Sri Vashne College, thanks all of you for joining this mega event. And I am really delighted to see all of you in this pandemic situation of Corona all over the world. But you people are doing well, and your efforts are really very much appreciated. I am looking various known faculties in this webinar, and really it is a great occasion for our college that you people are deliberating on the issue. Since this is a technical issue and I am a finance person, so I cannot speak much on about this event, but I wish you all the best. Definitely you will, or you all will be enriched with the knowledge and deliberations of learned speakers. So I wish you all the best and all the best to this seminar and webinar. And I am really thankful for all of you for your kind invitation to me as a patron of this webinar. Thank you very much.
Thank you for your valuable address and words for our conference. Now, I would like to invite our principal, sir, Dr. Pankaj Kumar Vasne. Are you available? Are you available, sir?
Yes.
Yes, please. Continue, sir, your address, please.
Thank you. Good morning to all of you. Am I audible or not, Shiv?
Yeah. You are audible, sir. You are audible.
Okay. Today's national virtual conference on recent advances in analytical techniques 2020, obviously known as RAAT 2020, organized by Department of Chemistry, SV College, Aligarh, affiliated Dr. B.R. Ambedkar University, Agra, Center of Biomedical Research, Sanjay Gandhi PGI, Lucknow, in collaboration with Department of Science and Technology, Government of Uttarakhand, Department of Chemistry, Radhe Hari PG College, Kashipur, and Hemati Nandan Bahuguna PG College, Khatima. I am pleased that our college is one of the organizers and participating in such a wonderful 2 days virtual conference at national level. I think that this virtual conference will be lay a platform for the interaction among experts around the world, which aim to accelerate discoveries and major milestone in the field of science and technology. In this participation, professors, academicians, research scholars, doctors, healthcare, corporate, and others will express their views, their ideas, and I think that their views and knowledge will be very helpful and needful to all of us. On this memorable occasion, I extend my heartfelt congratulations to all associated with this event. I express my compliments to the organizer for their valuable efforts. Obviously, that my field is commerce management and finance, so that I can't give my views in the field of science and technology. But at the last but not the least, I am very thankful to the whole team of RAAT 2020, especially organizing secretary Dr. Ashish Kumar, Assistant Professor Chemistry, Hemati Nandan Bahuguna College, Khatima, and convener of this virtual conference, Shri Mr. Shiv Kumar Upadhyaya, Assistant Professor at SD College, Aligarh, Department of Chemistry. Thank you once again. Very thank you.
Sir, thank you. Thank you very much for your valuable words, which are highly motivated to us and honor all of us to listen from you. This series, now I would like to request our head of the department, Dr. Nirja Sharma, to address the conference chairs. Ma'am, please.
Okay.
Are you available, ma'am?
Hello.
Are you available, ma'am?
Hello. Am I audible?
Yeah, audible, ma'am.
Okay. Thank you, Shiv, for inviting me to talk to you on this platform. Respected Chief Guest, Professor Mittal, sir, and all dignitaries of this conference and participants, a very warm welcome to all of you in this two-day BECA event. It is really a moment of great pride for the Department of Chemistry, SV College, Aligarh, to organize this virtual conference along with Alumni Association and Development Program of our college and Center of Biomedical Research, Uttar Pradesh. This conference is being organized in collaboration with USERC, Department of Chemistry, Radhe Hari Government PG College, Kashipur, and Hemvati Nandan Bahuguna Government PG College, Khatima, Uttarakhand. As we all are witnessing that the onset of these strange times, when humans are bound to stay in and adapt to this new normal, digital conference like this is an example to showcase our audience, our resilience. The purpose of this virtual conference is to provide an opportunity, especially to the young researchers, to interact with eminent scientists coming from different corners of the country and provide a wonderful platform to all of us to network. The theme of this event is recent advances in analytical techniques, that is the most important pillar of every field of scientific research, as we all know, as science student. I am confident that the discussion and deliberations and innovative ideas will be definitely rewarding for teachers, academicians, research scholars, and students. This RAAT 2020 mainly focuses on novel approaches to analytical methods, chromatographic techniques, environmental analytical chemistry, analytical biotechnology, new instrumentation and equipments, regulatory issues, and biosafety and bioanalysis. I convey my best wishes for the success of this conference and believe the takeaway of this conference would catalyst further research in the field. At the end, it is my duty that I would like to thank Dr. Shiv Kumar Upadhyay and other organizers who took pain for to become a success of this conference. Thank you very much. Shiv.
Thank you so much, ma'am, for your very kind word address as a chair, ma'am. Thank you. Thank you so much. So now I would like to request our chief guest, sir, Professor Ashok Mittal, sir, Vice Chancellor, Dr. Bhimrao Ambedkar University, Agra.
नाम आ रहा है
Sir,
सुन रहा है
are you available, sir?
अंग्रेजी की बात आ रही है अशोक का नाम आया है
Are you available, sir?
अच्छा
So, sir, शायद अभी नहीं है। जैसे ही कनेक्ट होंगे हम सर की ब्लेसिंग्स को लेंगे। इसी सीरीज में हम लोग आगे बढ़ते हैं फॉर वोट ऑफ थैंक्स फॉर दिस इनॉग्रल प्रोग्राम। आई वुड लाइक टू इनवाइट
हिंदी में बोलो यार, मातृभाषा हिंदी है।
डॉक्टर महेश चंद वासने, एसोसिएट प्रोफेसर एंड चीफ प्रॉक्टर, श्री वासने कॉलेज, अलीगढ़। सर, यू आर वेलकम फॉर वोट ऑफ थैंक्स। सर, आर यू अवेलेबल?
बनाया आज इंग्लिश बक रहे हैं, कल अंग्रेजों से आजाद हुए, आज इंग्लिश बोल रहे हैं।
आर यू अवेलेबल, सर?
हाँ डॉक्टर शिव,
प्लीज कंटिन्यू योर वोट ऑफ थैंक्स।
आप मुझे सुन पा रहे हैं?
जी जी, बहुत अच्छे से सर, बहुत अच्छे से।
16 अगस्त की प्रभात बेला में आप सभी बंधुओं का अभिवादन। इस मैं प्रतिभाग करने वाले सभी लोगों का मैं अभिवादन करता हूं। आधुनिक भारत निर्माण के लिए आधुनिक शिक्षा पद्धति की आवश्यकता महसूस की जाने लगी है और भारत सरकार भी इस दिशा में अग्रसर हो चली है। इसी मंशा को मजबूत करते हुए डॉक्टर शिव कुमार उपाध्याय ने और उनकी समिति ने एक सुनियोजित पहल की है। डॉक्टर उपाध्याय कौन है, संक्षिप्त परिचय देना चाहूंगा। आप श्री वासने महाविद्यालय अलीगढ़ के केमिस्ट्री डिपार्टमेंट में असिस्टेंट प्रोफेसर तो हैं ही, साथ ही एलुमनाई अफेयर्स एंड डेवलपमेंट प्रोग्राम का दायित्व भी पूर्ण निष्ठा के साथ निभा रहे हैं। इन्होंने और इनके सहयोगी डॉक्टर आशीष कुमार ने एक नेशनल वर्चुअल कॉन्फ्रेंस ऑन रिसेंट एडवांसेस इन एनालिटिकल टेक्निक्स 2020 के आयोजन का गुलदस्ता सजाया है। इस गुलदस्ते में मुख्य रूप से केमिस्ट्री डिपार्टमेंट एंड एलुमनाई अफेयर्स एंड डेवलपमेंट प्रोग्राम श्री वासने महाविद्यालय अलीगढ़ और सेंटर ऑफ बायो मेडिकल रिसर्च लखनऊ उत्तर प्रदेश की अहम भूमिका है। इस आयोजन के गुलदस्ते में फूलों की महक पैदा की है उत्तराखंड साइंस एजुकेशन एंड रिसर्च सेंटर एवं केमिस्ट्री डिपार्टमेंट राधे हरि गवर्नमेंट पीजी कॉलेज काशीपुर उत्तराखंड तथा हेमवती नंदन बहुगुणा गवर्नमेंट कॉलेज खटीमा उत्तराखंड ने। उत्तराखंड की समस्त रूपरेखा डॉक्टर आशीष कुमार असिस्टेंट प्रोफेसर केमिस्ट्री डिपार्टमेंट हेमवती नंदन बहुगुणा गवर्नमेंट कॉलेज खटीमा ने तैयार की है। इस आयोजन के गुलदस्ते की खुशबू लेने का अवसर मुझे भी मिला है। मैं दिल की गहराइयों से आयोजकों से जुड़े हुए सभी विद्वानों का मुझे धन्यवाद प्रस्ताव करने का अवसर प्रदान किया। इस आयोजन में विश्वविख्यात विद्वत्तजन जुड़े हैं और जुड़ रहे हैं, तब तो और भी आधार बनता है कि पुनः आप सबका आभार व्यक्त करूं। धन्यवाद प्रस्ताव के क्रम में सर्वप्रथम मुख्य अतिथि माननीय कुलपति डॉक्टर भीमराव अंबेडकर विश्वविद्यालय आगरा प्रोफेसर अशोक मित्तल साहब का धन्यवाद करना चाहूंगा। अपने व्यस्ततम समय में से इस आयोजन के लिए आशीर्वाद का आप एक विश्वविख्यात शिक्षाविद अर्थशास्त्री हैं। आपकी उपस्थिति इस आयोजन की गरिमा को 4 चांद लगा चुकी है। मुख्य संरक्षक के रूप में अपने आशीर्वाद गुप्ता साहब जो अपने साथ टेक्सटाइल एंड फाइबर इंजीनियरिंग का ऐसा अनुभव संजोए हुए हैं जिनकी वजह से आप अंतरराष्ट्रीय ख्याति प्राप्त अर्जित कर चुके हैं। ये मेरा दूसरा अवसर है जब गुप्ता साहब को धन्यवाद कहने का सौभाग्य प्राप्त हुआ है। इसी क्रम में मुख्य संरक्षक के रूप में प्रोफेसर दुर्गेश पंत साहब का आभार है। इस आयोजन की वेला में अपनी उपस्थिति देकर हम सभी को गौरव का अनुभव कराया है। आप रिसर्च के डायरेक्टर होते हुए भी इस आयोजन की सफलता हेतु हमारे बीच उपस्थित हैं। विशेष धन्यवाद के हकदार हैं। मेरा आपको नमन है। संरक्षक के क्रम में सर्वप्रथम मैं श्री वासने महाविद्यालय के प्राचार्य डॉक्टर पंकज कुमार वासने साहब का धन्यवाद करना चाहूंगा। आप एक कर्मठ, लगनशील, व्यवहार कुशल, सुयोग्य प्राचार्य हैं जिनके निर्देशन में महाविद्यालय प्रगति पथ पर अग्रसर है। मैं आपका आभारी हूँ। आपने अपना आशीर्वाद देकर इस कार्यक्रम की शोभा को 4 चांद लगा दिए हैं। संरक्षक के द्वितीय क्रम में सीए अतुल गुप्ता साहब का धन्यवाद करना चाहूंगा। उन्होंने इस आयोजन की माला में हीरे जैसे व्यक्तित्व के नग को पिरोकर 4 चांद लगाए हैं। आप श्री वासने महाविद्यालय के सचिव पर पुनः सुशोभित हैं। इससे यही स्पष्ट होता है कि आप ईमानदार, कर्मठ, लगनशील और समर्पण भाव से महाविद्यालय की प्रगति हेतु प्रतिबद्ध हैं। मैं हृदय की गहराई से आभार प्रकट करता हूं और धन्यवाद देता हूं। इसी क्रम में प्रोफेसर कमल के पांडे साहब, प्रिंसिपल एसबीएस गवर्नमेंट पीजी कॉलेज रुद्रपुर उत्तराखंड का धन्यवाद करना चाहूंगा, जिनकी गरिमामयी उपस्थिति आयोजन की सुगंध को बढ़ाकर सभी पक्षों मसलन विद्वानों, प्रतिभागियों, विश्वविद्यालयों, संस्थानों, विद्यार्थी आदि को सुभाषित किया है। इसी क्रम में प्रोफेसर चंद्रराम, प्रिंसिपल आरएच गवर्नमेंट पीजी कॉलेज काशीपुर उत्तराखंड की उपस्थिति ने इस आयोजन की पूर्णता का आभास दिया है। मैं दिल की गहराई से उनका धन्यवाद करना चाहूंगा। इसी क्रम में प्रोफेसर आरसी पुरोहित, प्रिंसिपल एसएनबी गवर्नमेंट पीजी कॉलेज खटीमा उत्तराखंड का सानिध्य हम सभी को मिला है। इस कारण आयोजन के सभी पक्ष आत्मविभोर हैं। ऐसे व्यक्तित्व को नमन करता हूं और धन्यवाद प्रेषित करता हूं। इसी क्रम के अंत में धन्यवाद करना चाहूंगा डॉक्टर बीडी उपाध्याय, प्रिंसिपल धर्म ज्योति डिग्री कॉलेज अलीगढ़ यूपी का, जिनके संस्कारों की छांव में डॉक्टर शिव कुमार उपाध्याय जैसा अनुज हीरा इस आयोजन की रीढ़ है और उनकी समिति ने इस भव्य कॉन्फ्रेंस को भारत के उन्नयन के कदम का एक दर्श कराया है। मानद अध्यक्ष के रूप में प्रथम मैं प्रोफेसर मंगला जोशी आईआईटी दिल्ली का धन्यवाद कहना चाहूंगा। उनकी गर्मामयी उपस्थिति और नूतन एवं गूढ़ व्याख्यान तथा ज्ञान की सरता से इस आयोजन में समस्त प्रतिभागियों एवं विद्वान अपित होंगे, ऐसा मेरा मानना है। इसी प्रोफेसर विवेक कुमार आईआईटी दिल्ली को धन्यवाद देकर सम्मानित करना चाहूंगा कि वो अपने गूढ़ ज्ञान से उपस्थित समस्त प्रतिभागियों को आकर्षित कर आयोजन को सफल एवं संचालन में अहम भूमिका निभाएंगे। इसी क्रम में प्रोफेसर अजय एचओडी केमिस्ट्री, डॉक्टर अंबेडकर विश्वविद्यालय आगरा का धन्यवाद करना चाहूंगा। इनके सार गौरवित व्याख्यान एवं नूतन विचारों से सभी प्रतिभागी लाभान्वित होंगे। साथ ही इस आयोजन की को अपनी दूरदृष्टि से नई दिशा प्रदान करेंगे। इसी क्रम मैं प्रोफेसर मुकेश कुमार सिंह, डायरेक्टर यूपीटी टीआई कानपुर का धन्यवाद करता हूं कि उनकी सहभागिता से ही मेरे लिए गौरव का विषय रहा है। वो निश्चित ही इस आयोजन का अविस्मरणीय व्यक्तित्व होंगे एवं आयोजन को नई दिशा प्रदान करेंगे। इसी क्रम में डॉक्टर ओपी नौटियाल, साइंटिस्ट यूसर्स देहरादून उत्तराखंड का धन्यवाद करना चाहूंगा कि वे अपने उच्च स्तरीय ज्ञान एवं अनुभव को आयोजन में प्रतिभाग कर रहे प्रतिभागियों के साथ साझा करेंगे, जो सभी के लिए उपयोगी साबित होगा। संगोष्ठी के अध्यक्ष के रूप में डॉक्टर नीरजा शर्मा, एचओडी केमिस्ट्री, वासने कॉलेज अलीगढ़ को धन्यवाद देना चाहूंगा। डॉक्टर शर्मा ने आयोजन में शिरकत कर अपने विचारों से रूबरू कराएंगी। संगोष्ठी अध्यक्ष द्वितीय के रूप में उपस्थित भूपेंद्र तिवारी, एसोसिएट प्रोफेसर सीबीएम आर लखनऊ यूपी को धन्यवाद हूं, जिनकी शोध परक ज्ञानमाला सभी को लाभान्वित करेगी। संगोष्ठी सह अध्यक्ष के क्रम में प्रोफेसर भानु नंदन, प्रोफेसर राजीव श्रीवास्तव, डॉक्टर सुशांत बरघेसे, डॉक्टर दिलीप गुप्ता को धन्यवाद देना चाहता हूं। इन सभी की गर्मामयी उपस्थिति से आयोजन को एक दिशा मिलेगी। आयोजकों में प्रोफेसर शिव कुमार उपाध्याय एवं डॉक्टर ममता बेलवाल का विशेष धन्यवाद, जिनके अथक प्रयासों से ये कॉन्फ्रेंस आयोजित की गई, आधुनिक भारत में अहम भूमिका निभाएगी। यह सह आयोजकों का भी दिल की गहराइयों से धन्यवाद, जिनके प्रयास इस आयोजन को एक नई रोशनी की किरण देंगे। सभी आयोजन सचिवों का धन्यवाद करना चाहता हूं, जिनके कारण महत्वपूर्ण कॉन्फ्रेंस होने जा रही है। प्लेनरी स्पीकर्स का भी धन्यवाद करना चाहता हूं कि वे अपने गूढ़ ज्ञान एवं ओजस्वी व्याख्यानों से समस्त प्रतिभागियों का मार्गदर्शन करेंगे। कीनोट स्पीकर्स का भी विशेष धन्यवाद, जो इस कॉन्फ्रेंस को ज्ञान की चरम सीमा तक ले जाएंगे। नेशनल एडवाइजरी कमेटी का विशेष धन्यवाद, जिनकी सलाह आयोजकों का मार्गदर्शन करती रही है। ऑर्गेनाइज स्टूडेंट्स कमेटी, टेक्निकल कमेटी का विशेष धन्यवाद, जिनके सहयोग से ये कॉन्फ्रेंस का गुलदस्ता सजाया जा सका है। एक बार अंत में पुनः आप सभी जुड़े लोगों को दिल की गहराई से धन्यवाद करता हूं और कॉन्फ्रेंस के उज्जवल भविष्य की कामना करता हूं। यदि भूलवश या समय की कमी के कारण कोई पक्ष अछूता रह गया हो तो उनका भी धन्यवाद करता हूं और अपनी शुभकामना प्रेषित करता हूं कि ये कॉन्फ्रेंस मील का पत्थर साबित होगी और इस कॉन्फ्रेंस से सभी पक्ष लाभान्वित होंगे। सभी का धन्यवाद, अभिवादन और नमन। धन्यवाद।
Thank you so much, sir, respected sir, for giving a very elaborative vote of thanks and to all of us. Sir, thank you so much again. Now, looking towards our technical session. Next session, technical session. For that, chairpersons are Professor Vivek Kumar, Professor Center Rural Development and Technology, IIT Delhi, and Professor Chitra Pandey, Kumayu University, DSV Campus, Nainital. And plenary speaker is Professor Mukesh Kumar Singh. About some chairperson, Professor Vivek Kumar. The chairperson for the session is Professor Vivek Kumar, Center Rural Development Technology, IIT Delhi. His research interest lies within the waste water and water treatment, solid waste management, enzyme application, mathematical modeling, pulp and paper, etc. He has contributed a lot in the field of research and development. He has published more than 131 research articles in reputed international journals. He is also the member of Unnat Bharat Abhiyan project and is one of the active person to work with this national level project. The Unnat Bharat Abhiyan project is the platform which enables higher educational institutions to work with the people of rural India in identifying development challenges and evolving appropriate solutions for accelerating sustainable growth. It also aims to create a various cycles between society and inclusive academic system by providing knowledge and practices for emerging professions to upgrade the capacities of both the public and private sectors in responding to the development needs of the rural India. He has also been member of the organizing committees of number of international and national conferences, seminars, and workshops. So the list is so long for the achievement and work is cannot be described here in few minutes. So I request you, Professor Vivek Kumar, to grace us by taking seat as chairperson for this session. Now, next chairperson is Professor Chitra Pandey, currently working as professor in Department of Chemistry, DSB Campus, Kumayu University, Nainital, Uttarakhand. Professor Chitra is a renowned chemist with 30 years of research experience. She has completed her MSc in 1984 and PhD in 1991 degree from Kumayu University, Nainital in organic chemistry. She is gold medalist in her academic. His research interests are organic chemistry, natural food chemistry, soil chemistry. About 58 research papers of her work were published in the leading national and international journals. She supervised 13 PhD theses, 9 awarded and 4 ongoing. 6 book chapter, 6 projects, 4 completed, 2 ongoing. She is the member of Essential Oil Association of India, Central Himalayan Environmental Association, Indian Association of Pharmacology, Chemistry, Teachers Association Organization for Women in science for the development of world Italy. The list is so long for achievement of work is cannot be described here in few minutes. So I request you, Professor Chitra Pandey ma'am, to grace us by taking seat as a chairperson for the session. Thank you, ma'am. Thank you so much. Plenary speakers, Professor Mukesh Kumar Singh. Now I would Professor Mukesh Kumar Singh. Professor Singh had joined the UPTTI in 2009 as a senior lecturer weaving. He has done his PhD from IIT Delhi in the year 2010. He has done his MTech from CSJM University Kanpur in the year 1999. He is also the member of various committees like Institutional Engineers, India, Textile Association of India, etc. He has published many research articles in various national and international journals. He has taken 20 professional trainings from different institutes of the country like GCTI Kanpur, TTTTI Chandigarh, HBTI Kanpur, NCUTU Kanpur, IIT Delhi. In the field of textile, dyeing and printing, he has also written several articles in different magazines like 21st Century with Deodorant Fabrics, Man-Made Text India in July 2002, Fashioning, Processing and Systematic Approach Textile Magazine, May 2002. So he's a very vibrant and is always very active and enthusiastic to his works. First, Sir Professor Mukesh Kumar Singh for deliver your plenary talk, sir. Are you available, sir?
Allow me for the screen share.
Om ji. Om ji. Om ji. ओम जी आप सुन पा रहे हैं मुझको?
जी
प्लीज प्रेजेंटेबल बनाइए सर को।
जी हाँ से बनाया हुआ है।
अपनी स्क्रीन
My screen is visible now.
Yes.
Hello. Hello.
यस मुकेश सर।
Hello, sir. Speak something.
Presentation, please.
सर कल भारत आजाद हुआ, आज इंग्लिश में बोल रहे हो, ये तो गलत बात है। कल तो अंग्रेजों से आजाद हुआ।
प्लीज म्यूट, प्लीज आई एम रिक्वेस्टिंग यू प्लीज। All of you are requested, please wait for some time. There is some network issue, please. We will connect soon. दो तीन मिनट का टाइम लगेगा सर, दोबारा से ज्वाइन कर रहे हैं, ऐड कर रहे हैं, प्लीज सो वेट। Sorry for little bit inconvenience. Please, is connecting soon.
नहीं चल रहे
Stay tuned, please. We will join as soon as possible, please.
So,
जी sir, जी, you are audible, sir. Share screen, sir. You are audible.
okay.
Yeah, sir. Yeah. Visible.
Okay.
Yeah, perfectly, sir. Please continue.
Good morning. Good morning to everybody. Sorry for delay due to some technical error on my laptop. I will talk about the particle size analysis today. Everybody is working and everybody is very interested to know the field of nanotechnology. When we start to work with the nanotechnology, we have to be very clear about the size of different material particles. So the particle size analysis is very effective analytical technique, which is essential in all about. I think it starts from chemistry, and it may go up to the fiber optics and all type of fields because matters. And small things are more smart nowadays. So if you will see the particle size, then you will find the particle size distribution is also equally important. Zeta potential, that is the charge which is present on the surface of any particle, that is called as the zeta potential. If you will see the basic definition of nanoparticle, then you will find initially there was the one definition. If any one dimension of a particle that remains in the slab of 1 to 100 nanometer, that considered as nanoparticle. But nowadays, there are some other definitions also. On the basis of those definitions, if 50% particles of any material, they remains in the slab of nanometer, then we can say those particles are nanoparticles. So in this way, different definitions are coming day by day as per the applications and need of different materials. You will see the particle applications. Then it starts from pharmaceutics. It goes up to various type of chemicals, building materials, especially the cement, plaster. It goes up to the aerosol size measurement in science. Environment is also equally important issue nowadays. Medical textiles, various type of coating materials, food and beverages. So these are some major applications. Apart from these applications, there are some other applications also which are difficult to. If you see the dimension, then you will find a particle dimension. You will see a particle is complete sphere. No. Particle is completely cube. That is again no. So we have to define various type of particle in different way. You can start from diameter of sieve, because this is the oldest technique to define the particle size. So if a particle that pass through a particular sieve, then we can say the size of particle that is less than the diameter of that particular orifice which is available in that particular sieve. Then another way, that is a d minimum, the diameter which is minimum to that but equal to that particular sphere. Then sphere of identical weight, then we can define the size of that material or particle in the form of dw. Sphere of identical volume, then we can say this is dv. Then sphere of identical sedimentation rate, DSED, sphere of area, DS, and spherical sphere of identical maximum length, Dmax. So these are some ways to define the dimension of a particle. Generally, the particles, they are very irregular in their size. They are not completely sphere or cube or any other defined shapes. So if you will see the some pictures of particles which are present in nano range, then you will find in left picture shape. We have taken finite element analysis of that particle, then we divided that particle shape in very fine squares. Then another way, how can we define the particles in a traditional way in terms of mean, median, and mode? So particle size generally we put on x-axis, and frequency of distribution of that size on y-axis. So if you will say this is the median of that particle, it means the median is the middle value when a data set is ordered from least to greatest. Mode is the number that occurs most often in a data set, and the mean value, that is the average, the total of numbers and then divided by total numbers of a set. The shape detection. Most of the particle size analyzers provide particle size in one dimension and generally mentioned on y-axis, and the particles on x-axis in two-dimensional representation system. So here, these are two very common way of particle shape. This is Martin's diameter. Here you can see in this figure. So Martin's diameter is that span of length which is projected parallel to the horizon. And then another way, projected area diameter, that is cross way. And then another diameter, that is the Ferret's diameter. Ferret's diameter is that diameter inside that the particle gets fit. So these are some way, like another picture you are seeing that the minimum dimension. Minimum dimension is that if you fit that particle in any way, the particles go in through that particular space. So that is called as the minimum dimension. And sieve dimension, that is the maximum dimension through which a particle can go through. So these are the particle size measuring techniques. The various type of measuring techniques nowadays across the globe. Various particle size measurement or analyzers, manufacturers, they are offering different type of techniques. So you can start from filter velocimetry, then it will go to morphological imaging system, laser diffraction system, resonant mass measurement, nanoparticle tracking, dynamic light scattering, and Taylor dispersion analysis. If you will see in totality, then you will find that 60 to 70% particle size analyzers, they are working on the principle of dynamic light scattering. So that is the most popular technique to analyze various type of particles. Okay. If you will see picture the particle size measurement techniques, then you will find that morphological imaging technique. This imaging technique is capable to find out the particle size in the range of 1 micron to 3 mm. Another technique, that is spatial filter viscometry. This technique is capable to measure the particle size from 50 micron to 5 mm. Another technique, laser. This technique is capable to measure the particle size of particles from 10 nanometer to 3.5 mm. Resonant mass measurement technique. This technique has potential to measure the particle size in between 50 nanometer to 5 micron. Nanoparticle tracking analysis. This technique is capable to measure the particle size from 30 nanometer to 1 micron. Dynamic light scattering technique. This is most versatile technique nowadays and most common also, user-friendly also. So dynamic light scattering technique is capable of particle size from 1 nanometer to 1 micron. So maximum which are used for various type of drug delivery system, they comes under the category of this, and they can be easily analyzed by dynamic light scattering technique. The latest one is Taylor dispersion analysis, and this technique goes below than 1 nanometer. So 0.2 nanometer to 20 nanometer. So most and most advanced technique is this technique. Now I will discuss about various techniques in brief. So, if you will see the technique to measure the particle size, then the SEEP oldest one and traditional one also. So for this SEEP, we use SEEPs in graduate. So in left picture you are seeing SEEP which has the orifice size 10 mm, then 1 mm, then 500 micron, then 250 micron, and then 120 micron. So if you will try to segregate the particles which have various sizes, then we will fix these SEEPs in gradual manner, and then the distribution of particle will take place. So in that way, we can define that these particles have this much of particle size, and then average out. So mean value, median value, and mode value, that can be calculated mathematically. But this technique will not give you the mean, median, and mode values. This technique will separate out the various particles according to their sizes. This is another technique that is called as the spatial filter velocimetry. The particles transported vertically through transverse laser beam. Then linear fiber array photodetector is at axial end of that particular laser beam. After that, a spatial sensor also integrated to sense and capture the shadow movement of those particles. Then a filter, specific filter to filter the image of moving particle and for calculating the speed. So you can say the role of image processing that become very important, and a very effective software is required to assist this technique and to get the proper and precise results for particle size analysis. An application of a fixed frequency pulse signal mixing measurement is also equipped, and this is capable to make the particle movement time measurement simultaneously. Then the particle chord length and particle size measured with a measurable moving, and the elapsed time estimation is calculated. So this is the pictorial view of this spatial filter velocimetry. In this picture, that there is a illumination object where the illumination will take place, and the particles will come in front of that illumination object. Then there will be a object lens that will give the picture on a spatial filter where the grids will remain situated parallel to each other. So the focal length will make the image at that particular grid, and then the image processing will take place with the help of this photo detector. And then with the help of the software which is based on processing, will give you the particle size, number of particles which are present in various classes, means how many particles they are landing from 1 nanometer to 5 nanometer, and then 100 nanometer to 500 nanometer, and 1 micron to 500 micron. So in this way, the classification of particle size will take place. This is another technique that is called as the morphological imaging. Inside this technique, a high-speed video camera is used to capture the image of various particles their appearance, their length, width, and the circularity. After getting the image, then the software is equipped to analyze the image appearance, length, width, and circularity, and then we get the equivalent diameter statistics in the form of mean, median, mode, distribution, what kind of distribution those particles are following. Are they following the normal distribution, or they following the other type of distribution? So only bright and dark surfaces of particles are captured. So this is the limitation of this technique. Means if a particle has some colored appearance, then it will be difficult to capture with this technique. If the image will capture, but the accuracy will affect it. It's called as the laser diffraction technique. So this technique is used to calculate the average particle size by macroscopic view of particles. So the various, if you will see the various type of scattering, then you will find the Mice scattering concept states that various diffraction processes are generated when laser beam irradiated a group of particles which are varying in size. So the radius of particles and laser light wavelengths becomes very close to each other, and maximum part of laser light get diffracted, and pattern of laser light spot looks more focused and clear. So in this way, this laser diffraction techniques works. Conversely, as laser light beam irradiated a small size particles, then laser light wavelength, most of the laser light travels without diffraction, and the laser spot pattern look more diffuse and fuzzy. So the high number of photodetectors are selected to be used in various laser particle size analyzers to cover the angular range around 170 degree of the scattered light of laser and angle. And intensity of scattered light is estimated by means of an image sensor. So this setup provides the particle size distribution on a particular described map. So this is a technique which you see here in pictorial form, as I have already discussed that there will be a laser. So here I have mentioned the helium neon laser sources there. Then there is a filter, then another special filter to filter out and to get a particular length of that particular laser. Then there will be a flow cell, which where the back scatter laser light will detect by means of a detector. There will be another blue light source to enhance the intensity of this technique. When this the image of various particle will capture on focal plane, then a focal plane detector will detect the images of all those particles, and then small angle and large angle detectors will work, because I have already mentioned the 170 degree reflection of that laser light that will be detected by means of these detectors. So large angle detectors as well as small angle detectors are placed inside this technique. So this is the concept of Mice scattering. You will see this is called as the this is based on Fraunhofer diffraction technique. If you will see the particle light wave particle laser beam, then there will be a particle which comes in the way of this laser beam. Then you will find, as per the Fraunhofer diffraction, some part that will go direct, some part will reflect, and some reflection will also take place. So this will follow the sine theta n equal to n lambda upon x, where theta is diffraction angle, which is inversely proportional to the particle size x, and n is the number of diffraction angle, which we take in radians. Particle size. So that this Mice scattering concept that is based on diffraction plus reflection and refraction. Nanoparticle tracking analysis. This is also another advanced technique for nanoparticle size analysis. This is common to determine particle size of biomedical objects. Stokes-Einstein kinetic principle is base for this technique. In this technique, a laser light based video imaging system And high-speed particle tracking system is used to capture the images at microscopic level. So Stokes-Einstein kinetic principle that is very useful to track the small particles which are moving faster than large particles. This is the concept of Stokes-Einstein's kinetic principle that says that a small particle will move faster than a large particle. So the kinetic trapping or tracking will take place by means of this technique. The values of mobility and medium viscosity object. Stokes-Einstein equation is used to estimate the radii of those particles. If you will see the nanoparticle tracking analysis concept in pictorial form, then you will find there will be a laser source, and that will those laser light will come, and then there will be a beam mirror by which the direction of those laser light that will be directed other way, particularly at 90 degree. Then there will be a cell where the nanoparticle will present in terms of a solution, in terms of a powder. Then the zeta focusing instrument that will focus the image, and then video will capture the images of all those particles. In this way, the cross-sectional view of those particles is also possible, and this filter can slide up and down, so we can capture the images of particle in at various points, at various surface of the sample. Sample may be present in terms of powder, that may be present in terms of liquid, in terms of colloid, in terms of in various forms. Sample may present, and sample may cap successfully and can analyze by this technique. As you, I have already mentioned, the dynamic light scattering technique, DLS. This is most popular technique nowadays. So particle dispersed in solution doesn't rest in stationary condition, but act in Brownian motion continuously. This is the concept. This is the base to understand dynamic light scattering. Photosensors are also integrated with this setup to detect the scattered on the diffusion coefficient is calculated by modifying the intensity of scattered light. Finally, the estimated values are used in Stokes-Einstein equation to calculate the particle size. As I have already mentioned, the Stokes-Einstein equation says that the small particles moves faster in comparison of big particles. So if you will see this method is suitable to measure the particle size which are landing in the diameter equivalent to 10 nanometer to 11 micron. So most of the small particles, they comes under this range. There may be some particles which are lesser in size than 10 nanometer. Then we have another technique to analyze those size precisely. The results of dynamic light scattering technique remains very close to Z average to present the intensity weighted average. If you see the Z average molecular weight, then you will find the results of DLS technique, they comes very close to that average. This is also calculated by this technique. The concept of particle size analyzer is based on Brownian motion of particle, and the intensity of scattered light is captured by means of very sensitive detectors and cameras. The intensity of scattered light gets changed due to Brownian motion of particle, as I have already mentioned, that smaller size particle move faster. So the intensity of their movement that will be higher in comparison of bigger size particle. In this way, this technique will capture the size of those particles. So these quick intensity. These quick intensity changes in scattered light is captured and analyzed particle size on the basis of Stokes-Einstein theory. Finally, the DLS is widely accepted technique due to its precise repeatability and need of very small amount of specimen. In this way, I have mentioned that DLS technique is more precise technique, more promising technique, and the beauty of this technique is its consistency or repeatability of data. If you will compare with other techniques, then you will find there are some issues with the consistency of data. If you will check the same sample at 4 or 5 times by other techniques, then you will find a little bit difference. But if you will test the same sample number of times with the DLS technique based instruments, then you will a very promising results or precise results with promising repeatability. So this is the concept of this DLS technique. There will be a laser light source, then there will be a lens, then sample will kept in a particular sample holder. When the laser light that will incident on the sample holder, the scattering of laser light will take place, and the scattered light will detect by photon detector. And then the signal they will correlate, and diffusion coefficient and particle size information will process, and that will be present with the help of software on the computer screen. So in this way, this dynamic light scattering technique is very user friendly, very promising, because the Brownian moment of particles, which are very small in size, that will capture precisely. This is the next one, or you can say the most sensitive technique nowadays, that is called Taylor dispersion analysis. So most advanced technique of particle size measurement, which is used to measure the particle size less than 10 nanometer, which is generally found in drug carrier in medical science or by pharmaceuticals. The sample solution is injected into the micro capillaries and sample start to move. The cross-section of capillary is measured continuously by a ultraviolet spectroscopy. UV estimated the absorbance of UV light by a sample particle which is passed through the capillary cross-section at a fixed frequency. Why the fixed frequency is used? If you will change the frequency, the absorbency will, you will not get the precise results. So the frequency that will remain constant, and the particle will change as the particle size will change, absorbance will change. The absorption versus time graph that is called as the Taylorogram is obtained by means of this technique. A bell curve is obtained by this graph, which exhibits the change of concentration of particle through the cross section. This way, the diffusion coefficient of the kinetic theory on the basis of analysis of width of the curve that is calculated. The Stokes-Einstein equation used to calculate the particle radius also. So as I already mentioned, the Stokes-Einstein concept is used in other techniques also, like scattering technique, and this again, this Taylor dispersion analysis technique is also used the Stokes-Einstein equation. Only difference is that here we are using the very fine capillaries, but in case of a DLS technique, the sample is placed inside a sample holder. So this is the concept of analysis. Here you are seeing the very fine capillary which is present here. And the solution will pass through continuously through this capillary. You can see the lipolysis of self-emulsifying lipid-based acceptant that also be placed inside a particular beaker, and then you can transfer that liquid with the help of this instrument attachments. Here you are seeing a graph where we have mentioned the lipolysis time in minutes and then the size of particle in nanometer on y-axis. So this is a very sensitive, very costly, and very useful also technique. But only difference is that this is user friendly. A very you can say skilled person is required. Highly skilled person is skilled operator is required to operate this technique to get the precise results. This is another way to clarify the concept of this Taylor dispersion technique. Here we are seeing the outlet and inlet, and this is a loop of capillary loop of this capillary tube, and the particles which are mixed inside the solution which we are feeding through this capillary. So the continuous measurement by means of UV spectrophotometer will take place, and the absorbance will calculate as a function of time. So then we will get the particle size with the help of software processing, and the technique will provide you very precise results up to 0.1, 0.3, 0.4, means in less than 1 nanometer size also. Non-invasive back scatter. There are some other techniques which are available at research scale. Instruments, as per my knowledge, my information, on the basis of these techniques, instruments are not available, but various research groups, various scientists, they are trying to establish these technology, and so that on the basis of these technology, ultra fine measurement of particles will become available in near future. So non-invasive back scattering, NIBS technique, that is the combination of back scatter detection and variable measuring position. This technique enhances the analysis power of particle size analyzers to scan the specimen of different concentrations in comparison of conventional DLS technology. So this is the base of non-invasive back scatter techniques. This is the cuvette where you will place your sample. This is the focus length, the laser source, and then the detector. So whatever laser light that will scatter by the presence of small size particle, that will detect very near to the laser source. So that scattering, or you can say the diffraction and reflection of laser light by the presence of those tiny particles will capture accurately. This is a laser diffraction. This technique detects the particles. You are not audible. Let me finish. Then I will discuss. Yeah. Laser diffraction. This technique.
Continue, sir.
Audio is not available.
There is some network issue, so please, there is some slides remain. So I'm requesting all of you, please stay tuned. He will join soon, and within 5 minutes, 4 to 5 minutes, please.
Okay, sir. Sure.
Yeah. Professor Chitra Pandey, ma'am, are you available, ma'am? Professor Chitra Pandey, ma'am, are you available?
जी हाँ सर, कनेक्ट है हूँ मैडम ना.
Okay.
Hello. Hello.
Yeah, ma'am. He will connect soon. Wait for 5 minutes, 4 to 5 minutes. There is a network issue, ma'am. Yeah,
Okay.
yeah,
Okay. ठीक है, I'm holding on.
yeah, yeah. Please, please, please. All of you are requested. There is some network issue, so please wait for 3 to 4 minutes. He will join us. He will join us.
It is my humble request and suggestion that some new speaker can speak something about the conference. It will be good for the all the participants and the
Sir,
delegates.
I'm requesting you, sir. Please wait only for 2 3 minutes. He will join. I'm regularly connecting with him.
ज्वाइन हो गए हैं सर वो।
हाँ, बिल्कुल बिल्कुल बिल्कुल. He knows very well all these things, which is there is some network issue and so many problems. So
Network or technical
bear
issue,
with
maybe
us,
he has
please. All of you are requested. All of you are requested.
कैसे इसमें जब इस टाइप की टेक्निकल दिक्कत आती है इन बिटवीन ऑर्गेनाइजिंग टीम कैन ऑर्गेनाइज और से समथिंग अबाउट द ऑर्गेनाइजर ऑल्सो भी
प्लीज
जितनी इतनी जानकारी इसमें जो है अपने ऑर्गेनाइजर अलग हो सकती है कॉलेजेस और इंस्टीट्यूशन उनके होता है कोई ना कोई इंस्टीट्यूशन के बारे में बताएगा तो इट विल बी गुड, ये सभी के लिए फैमिलियर भी हो जाएगा और टाइम विल बी यूटिलाइज इन द
Yeah,
पॉजिटिव वे, आई थिंक
he is connecting now, sir. He's connecting now, sir. Please. Thank you, sir, for your advice. Thank you so much.
Am I audible?
Yeah, sir. You are audible, sir. Please continue.
Sorry for this technical disturbance.
Yeah.
I was talking about the laser diffraction. This technique detects the particle size in the range of 500 to 1 lakh of nanometer, or you can say the
Sir, you are not audible.
Respected Mukesh, sir, you are not audible. Please. So I'm requesting your Professor ma'am. There is some network problem from sir side, sir. So you can summarize the session because almost the session was almost at the end. So there is one or two slide was left. So please you can summarize as a chairperson. Please. Then we will move on the next plenary speaker. Professor Chitra
Hello?
Pandey, ma'am. Yeah, you are audible, ma'am.
Can you hear me, sir? आप मुझे सुन सक रहे हैं? हेलो?
हाँ, प्लीज मैम, आपकी आवाज आ रही है मैम.
रही है. Okay, thank you so much. Thank you, sir. So,
Please.
thank you. I would like to thank Professor Mukesh Kumar for his excellent presentation. Because due to certain technical problems which happen now since we are starting a new era, COVID times to adjust, with him and summarize his findings, where he talked at length about particle size application, about shape detection, particle size measurement techniques. He moreover discussed some techniques in detail, such as the sieve technique, where this size, which separates the particles, size greater than 1 mm, and spatial filter velocimetry, morphological imagery, where mean, median, mode. But the drawback being that only bright and dark surfaces of particles, they can be captured. At the same time, he also discussed laser diffraction to calculate average particle size by microscopic view of particles, as laser light travels without diffraction, and then about my scattering. So it was a very interesting talk that way. At the same time, he also discussed nanoparticle tracking, which is used, this analysis, for biomedical objects, and also through some light upon Stokes' instance kinetic principle, which is used here. Then he talked about dynamic light scattering technique, which is most versatile. This is due to its precise repeatability and its consistency, because repeatability in science is very important, in fact. So then he talked about the most advanced Taylor dispersion analysis by obtaining Taylorogram. It is a very sensitive, but at the same time, it is very costly and not very user friendly, because a highly skilled operator is required for this. While he was talking about non-invasive backscatter, NIBS, this technology he talked about is, and he told us that it is still trying to be established. And while he was discussing laser diffraction, I think somehow the connection was not managed. So we thank you, sir. आपके ज्ञान और अनुभव ने यहाँ उपस्थित सभी पार्टिसिपेंट्स का बहुत ही ज्ञानवर्धन भी किया और मार्गदर्शन भी किया। और मैं ये मौका लेना चाहूंगी, I thank Shri Shiv Kumar ji for the kind words, Dr. Ashish Kumar. I congratulate the entire dynamic team for putting it so much effort. और मेरा अभिवादन स्वीकार करें आज के हमारे जो मुख्य अतिथि हैं, माननीय कुलपति महोदय डॉक्टर भीमराव अंबेडकर यूनिवर्सिटी आगरा, प्रोफेसर अशोक मित्तल, जो मुख्य संरक्षक आज के इस इवेंट के हमारे जो चल रहा है 2 दिन के लिए, भुवनेश गुप्ता जी, प्रोफेसर भुवनेश गुप्ता जी, प्रोफेसर दुर्गेश पंत, आज के संरक्षक डॉक्टर पंकज कुमार वाशनी, श्री अतुल कुमार गुप्ता जी, प्रोफेसर के पांडे, प्रोफेसर चंद्र राम, प्रोफेसर आर.सी. पुरोहित, डॉक्टर बी.डी. उपाध्याय, Dr. Nautiyal, and also to Dr. Nirja Sharma, Dr. M.C. Varshney, Dr. Ashish Kumar, and all the dignitaries who are present here. और जितने यहाँ समस्त उत्साहित छात्र व छात्राएं और शोध छात्र जिन्होंने बहुत मेरे ख्याल से इस डिस्कोर्स से काफी गेन किया होगा, तो मैं आप सभी मेरा अभिवादन स्वीकार करें और मैं सभी को कांग्रेचुलेट करती हूँ कि आप लोगों ने इतनी अच्छी तरह हम सबको एक समूह में इकट्ठा करके हमें भी मौका दिया to upgrade our knowledge. So thank you all. I end with these words. Thank you so much.
Thank you so much, ma'am, for your very nice and kind words and blessings and support. Thank you so much, ma'am, for giving a time also. So now in this line, we are moving for listening to our next keynote address from Dr. B. Sridhar from IICT, Hyderabad. So for this keynote address, there are 2 chairpersons, Professor Bhanu Nandan from IIT Delhi, and second chairperson, Dr. K.D. Verma, Department of Physics, Sri Vasne College, Aligarh. So chairperson, Professor Bhanu Nandan. The chairperson for the session is Professor Bhanu Nandan, Department of Textile and Fiber Engineering, IIT Delhi. Professor Bhanunandan studied polymer science at the Guru Jamshedpur University, Hisar, India. Subsequently, he worked as a research fellow at the Defense Research and Development Organization, India, in its Kanpur laboratory and obtained his doctorate in applied chemistry, that is polymer science, from Kanpur University in 2003. After completion of his PhD, he joined as a postdoctoral research in research group of Professor Hussein Lung Chen at the Department of Chemical Engineering, National Chunghun University, Taiwan. In 2006, he joined Professor Manfred Stem's research group at Leveraging Institute of Polymer Research there in Germany as a guest scientist. He joined Department of Textile in Indian Institute of Technology, Delhi, India in 2010 and is presently as associate professor in the same department. He has published more than 84 articles in international journals of repute and has in index of 26. His current research focus on application of fibers, materials and energy storage and catalysis, electrospinning, self-assembly in soft matter, coffee confinement effect in polymer crystallization and scattering techniques in polymer. He has been the member of many national and international committees. He is also dynamic personality and always full of enthusiasm towards his work. So I welcome you, sir, and it's an honor for us to connect with you. So Professor K.D. Verma is an eminent academician and researcher dedicated for development of the nanoscience and technology and computer engineering, has an outstanding educational record throughout. He always stood first division throughout his educational career and is gold medalist student of his time. He is recipient of national scholarship during his education. Dr. Verma rose the post of assistant professor, university lecturer of that time in the university campus in the age of 21 years, maybe the youngest assistant professor in his area. He completed BSc and MSc with first division in 1986 and 1988 respectively, Master of Philosophy with high first division in 1989 and Master of Technology with high first division and awarded PhD also. He earned his all degrees from accredited university with high grade by NEC and apex body of Government of India. He has more than 200 years teaching and research experience during this period of Burma. He has served as the various administrative capacities also. He has served as the Dean of Student Welfare, Chief Proctor, Convener, UGC Cell, Game Superintendent, and member of University. Flying Squad of conducting fair examination, examiner of evaluating PhD thesis of various universities. Examine for the theory as well as practical papers for various universities and several other important capacities. He has more than 50 research papers in his credit. He has published several papers in the journals having very high as impact factor. So I welcome you, sir, and it is an honor for us to connect with you. So little about our keynote speaker, Dr. B. Sridhar obtained his PhD degree in physics from Sri Venkateswara University, Tirupati in 1990. After attending PhD degree, he went to Ritsum University, Kyoto, Japan for his postdoctoral research. In 1998, he joined as the scientist in CSIR, Indian Institute of Chemical Technology, that is CSIR IICT, Hyderabad. Currently, he holds the position of Senior Principal Scientist in CSIR IICT Hyderabad. He was awarded the Best Research Publication Journal of American Chemical on CSIR Foundation Day and many more. He has lifetime membership for numerous peer-reviewed journals and he is also member of Board of Studies in different universities, colleges. He has expertise in the field of bioanalysis using natural gums, nanomaterials, and nanocomposites, heterogeneous and homogeneous catalysis, glass science, synthesis of advanced material using sol gel technique. Solid state spectroscopy, he has more than 379 research papers published in national and international peer-reviewed journals. 6 US patents and 143 papers presented in national and international conferences. He supervised 10 PhD theses, 8 awarded and 2 ongoing, 45 MTech projects works and 78 MSc projects works. So I welcome you, sir, and requested you to share your knowledge with all of us. Over to you, sir. Dr. Sridhar, sir, please continue your deliver it, please.
And it's always a pleasure. And I am really thankful for the organizers for giving me this opportunity. The other time, means earlier also, I spoke on one of the techniques, which was what was called X-ray photoelectron spectroscopy. And that is this instrument here, which you can see. But today I am going to talk about these nano-engineered materials, which I've been working for quite some time. But it's like a journey at IICT where I've used various analytical techniques for these kinds of analysis. So I'll try to explain you all these things, and by the end, I'll show you what are the techniques that I'm familiar with. And at any point of time, if you have any doubts, please don't hesitate to stop me and ask me a question. So to start with, these are the two instruments. This is what is called X-ray photoelectron spectroscopy. X-ray photoelectron spectroscopy, as the name suggests, the source is an X-ray gun. X-rays fall on the sample. Photoelectrons are ejected. These photoelectrons give us valuable information about the sample. The information that we get is, first is the elements present in the sample. That we can get from various techniques, like atomic absorption spectroscopy or inductive coupled plasma coupled to mass or OES and so on. And various other techniques are there where we can know, like EDAX or EDS. So you can know about those various elements present on the sample. But there is something different in this technique. The difference is, along with the elements, you can know their oxidation state and also their molecular environment. For oxidation state, by oxidation state, I mean, like, you have iron. Iron can be iron 2+ or iron 3+. So in this technique, you can not only know the elements like iron and its oxidation state like iron 2+ and 3+. Likewise, all the elements in their multivalent state, we can get information from this technique. The other one is like, you have aluminum oxide, which is the alumina, and you can, if you fluorinate it, it will become aluminum fluoride. So the environment around the aluminum is changing from oxygen to fluorine. So depending on the neighboring element, say aluminum or oxygen or aluminum or fluorine. So depending on its neighboring element, you can know that information also. So like that, the information that we get is the elements, their oxidation state and their molecular environment. One of the beautiful techniques, and about this I talked in my earlier conference, so I'm not talking about that here. The other one which is so dear to me is this transmission electron microscope, which I have been using since I joined the institute. And most of the images that you see on this first slide are from that instrument only. And I'm into this. So I will try to explain, go through my journey at IICT. And I'm sure all of you know about Indian Institute of Chemical Technology, where Ashish is our own alumni. And I'm glad to see that he is able to share, give us an opportunity to share our knowledge with some of his colleagues and friends around the Uttarakhand and other areas. It is always a pleasure. Keep you doing your best, and we wish you all the best, Ashish. Okay, now let us start with small definitions, and then we'll come back to the original thing. Well, nanoscience, as you know, is like any other science, is the phenomena and manipulation of materials. The only difference of manipulation of the materials is at nanoscale or atomic, molecular and macromolecular scales, where the properties of these materials are completely different from the bulk. Like an example here, you can see this gold ring, and all of us know gold is inert at room temperature and is pale yellow in color. But when it takes this, when you have this material in its nano dimension, it can take so many different colors, and which means that there should be something different. And let us try to understand what this difference is. Without any difference, there won't be so many different colors. So we will try to understand why these colors are so different and what is so different in that nano gold, and understand that. Before going further, I want to emphasize on this point, which is nanotechnology, and it is a multidisciplinary area where branches of all sciences and technology have to work together and bring out something useful to mankind. Like I've put here, it can be chemistry, it can be physics, it can be biology, it can be mathematics, all branches of engineering, agriculture, and medicine and whatnot. So all these branches of science and technology, engineering, medicine, all of us have to work together. And it is, though a multidisciplinary area, all of us, like maybe I'm a physicist, but my fundamentals in other basic sciences should also be strong, so that I can have an edge over others, and I can understand the language of chemists, I can understand the language of biologists, so that all of us can work together in a team and try to bring out something novel for mankind. And that is what is technology is, where you are designing, characterizing, producing, and application of these new materials with the novel properties by controlling their shape and size at nanoscale, where you are using them for developing new technologies. As was already mentioned by my earlier speaker, Mr. Professor Mukesh Kumar Singh, well, nanometer, I'm sure all of us know, it is a 1 billionth of a meter, which is about 10 to the power of minus 9 meter. What is important here is to understand is that it can take any shape. And if any one dimension is between 1 to 100 nanometer, it is a nanomaterial. So it is, for example, this sphere, well, all its dimensions are about the same. They are the same. So it is, if this diameter is 100 nanometers, it is a nanosphere. It is a nanopyramid. For example, this rod, it can be few microns in length, but if the thickness of the rod is less than 100 nanometers, between 1 to 100 nanometers, it is a nano rod. Similarly, this tube, it can be few microns in length, but if the internal diameter of the tube is less than 100 nanometers, it is a nano tube. So like that, these days, many different shapes are coming up, and depending on the shape, we are having various kinds of nomenclature like nano rice, nano flower, nano petals, nano what and so. I will try to show you some of those kind of images that I have seen myself in my journey at IICT. Why is this nanoparticle so interesting? Now, all of us are, I'm sure in the audience also, there would be many who are already working on nanoparticles and nanomaterials. So I want to make it interesting for the scholars and others to understand why is it that it is attracting so much attention. Well, we have already talked about size and shape, and that we have already put here. So it can take any shape or any size between 1 to 100 nanometers. Other than that, there are two other fundamental things that are making it so important. One is what is called the surface. The material is, of course, there. The kind of material that you use as the particle source, nanoparticle source. That is one thing. Like, it can be a carbon nanotube, it can be metal oxide, hydrogel particles, solid liquid lipids. So depending on the applications, like, when you are looking at drug delivery systems, you would be looking at biocompatible polymers in nanoscale, which can encapsulate the drug into that, and then you use it for your kind of application. So depending on your application, you have to look at the appropriate kind of materials and try to look at that. And the most other very important thing is the surface. You can tune the surface, play with it, and try to have different kinds of materials. Like, for example, let us look at hydrophobic and hydrophilic material. So appropriately, you can coat the surface and make it hydrophilic or hydrophobic, depending on the way you want it at the application site. Okay. Similarly, when you talk about catalysis, you can functionalize this surface and modify it such that you have a material which can be used for catalytic applications. I will try to explain that when I have done my work for catalytic applications. So that is why these 4 parameters, size, shape, materials, and surface, are the ones which are making these particles so interesting for various applications. Now, what are the conditions that are, mostly we are the challenges, let us say the challenges that are very important. So I have tried to put it down here. For fabrication of nanoparticles, a small size is not only the requirement. Size alone is not the requirement. There are other things that are also very important. First thing is you have to control the processing. That means you have a protocol. That protocol has to be designed such that you have particles of identical size. That is identical size of all particles, which is what is called monodispersed or monosized or uniform size distribution. Well, as Sir was talking about particle size distribution, this is one very fundamental thing, that they should be of uniform size, and one that is what is called uniform size distribution or mono-sized particles. Next comes morphology. When you are talking about a shape, for example, if you say that it is a nanocube, all the particles, most of them should be the same cube. Not only the size, but the cube should also be of the same form. Morphology should also remain the same. The next comes chemical composition. Like, for example, if you're talking about alumina, 100%, like the purity of the material depends upon that. So the whole material should be alumina. There shouldn't be any other impurities. So that is another very important thing, which is identical chemical composition and also the crystal structure. If it is amorphous, fine, no problem. But if they are uniform crystals, then the crystal size, crystal morphology, and the crystal chemical composition should also be the same. Then individually dispersed, there should not be any agglomeration. If they tend to get agglomerated and then form big bulk form, then most of the properties would be lost. So they should be individually dispersed or monodispersed. That is, there shouldn't be any agglomeration. So for that, these are some points on which I will try to talk. And at various stages of my talk, I will be addressing all these points so that things become clear by the end of the talk. Now, there are many factors that actually influence the interface or nanomaterials and other systems, because you try to put them in some solvent, and in the solvent there are many things that are happening, so which we call them as main physicochemical influences on the particle. So which can be in the surface of the nanoparticle, which we have already talked about: size, shape, surface area, charge, as was mentioned by Sir about that in the earlier talk. That is the zeta potential, which gives us the charge of these particles. So energy, roughness, functional groups, ligands, crystallinity, and as I already mentioned about hydrophobicity and hydrophilicity, depending on the surface modification, you can have that particle which is hydrophobic or hydrophilic. So depending on the medium in which it is suspended, it also has some influences, like, it can be water, or it can be some other organic solvents, and so on. It can be acidic condition or a basic condition. You can put it in as another salts, like, depending on your application, where when you have added other salts, those salts will have their own cations and anions. Those will also influence these particles. It's surfactants, polymers, polyelectrodes, depending on whatever is the application, appropriate solvents would be used, and it is that suspending medium in which these particles are dispersed, and that would also influence the particle. Then when they are in the solid and liquid, because if whatever liquid that you have taken, those things will also be there, and these are some of the effects that are possible, like aggregation, dispersion, dissolution. We have talked about that. And the zeta potential is what I mentioned in my earlier this thing. So these are all the things like charge neutralization, ionic adsorption, surface. These are all the things that are possible. And if you look at if it is a biocompatible material, then these bioparticles, these nanoparticles should be biocompatible, and if suspended in a biological solution like a phosphate buffer or so on, which mimics what is there in our human body. And in such cases, they also have an interface where these kind of things can take place. Like, like for example, it's a receptor ligand binding interactions. These days, when we are talking about COVID, there is a lot of discussion going on in various media where we are talking about antibodies, and this COVID has spikes kind of a thing. So people are looking for what's called this vaccines and all. So then what happens? So it's like a lock and key kind of a phenomena. So for an appropriate for a lock, it has only one particular key. So which is the lock and key kind of a model, which explains about this nano bio interface. So these are some things which are very interesting, where depending on their biological applications, it can interact with the DNA, it can interact with the mitochondria, it can go into the cell structures and so on. So depending on where and exactly it is there in the biological medium, it will have this nano bio interface. So these are the various things that are influencing these particles, and that is why it is drawing so much attention. Now, let us try to understand one thing very clearly. Nanoscience and nanotechnology, nanoscience, let us say, has been there since ages. It's nothing new. But what is new is the invention or the discovery of new advanced research techniques, analytical techniques, wherein we are able to see these materials, and not only seeing, we are able to understand the mechanism at that nanoscale, where they are playing a lot of difference when compared to bulk material. That is where it is actually making a difference. And as we are all having our own philosophy, seeing is believing. So until we see, we will not believe. That is human tendency. So here, this is what has made a difference. Microscopy, for example, you can see the scanning electron microscope images of two different materials very dear to us, silver and gold. Look at these cubes. They are all uniform in size. They're all of them, so many of them, but all of them are uniform in size and uniform in shape. So the first challenge is to prepare the materials of uniform size and uniform shape. Here you see gold boxes. They are also having faces, very almost similar in all these kind of materials. So like this, it is started working on. But before going to such advanced techniques, let us see how their solutions as such look when we talk about such materials. Here, I'm talking about silver nanoprisms of 100 nanometers, silver spheres of 120 nanometers, silver spheres of 80 nanometers, and silver spheres of 40 nanometers. If you look at the colloidal solutions, they look completely different in their color. Here you see they are red in color. This is like pale yellow and crayon color and dark blue in color. So the colors are completely different, not exactly like a silver metal or like a uniform in color, but it all depends upon the size and shape of these materials. If you look at these gold spheres of 150 nanometers, see the contrast in color. Now it's like it's mango yellow in color and this is green in color. So these colloidal solutions look in different colors. So first thing is their optical properties. Here we are talking about their optical properties. We are able to see a difference in their colloidal solution by our own eye. That itself gives us an idea that there is something different in these kind of materials. So depending on the protocol that we have used for synthesis. Okay. With that basic background, I will try to explain what I have been doing at IICT over the years. So I will be covering something about core shell nanoparticles, polyaniline nanostructures, how they make an influence on the catalytic properties, gamma acacia stabilized metal nanoparticles. This is something which we started some time back and we have done something here. How magnetic separable nanoparticles can be used for catalytic applications. I'm not talking about this area, which is biomimics and biomineralization, where we try to use natural gums for the synthesis of these kind of materials like strontium carbonate, barium carbonate and all in different morphologies like this. So we will talk about that sometime later. But let me talk about these few things and then try to explain what I have been doing at IICT for the last few years. Well, gum acacia, I'm sure all of you are very familiar with it. These neem trees in our campus or in our places, you normally see these kind of globules attached to these trees. These are what are called gum globules. And these gums are very compatible, and it's a very commonly used material, and it is being used in various usages in pharmaceuticals, cosmetics, paints, ornamental plants, and even in juices and all. So such kind of commonly available material, we try to use them for the synthesis of metal nanoparticles. And the beauty of this material is it has everything in it. Like, it is a good reducing agent. It is a crystal growth modifier. It is a what is called a surfactant or a stabilizing agent. So all these properties are inherently there in this material, which is like a crystal growth modifier and metal reducing agents. There are a few things that are very important in this. These OH groups that are present in sugars like arabinose and ramos, and these COH groups present in glucuronic acids, these are the ones that are crucial in the growth of metal nanoparticles for this means reducing metal ions into metal particles, or for the formation of metal carbonates when we talk about biomineralization or biomimicry. So let us not worry about that. But initially, it is these functional groups, OH and COH groups, which are responsible for reducing metals into their metal nanoparticles. And there is an the proteinaceous score, which is there in amino acids. This acts as a stabilizing agent for the for the application of these gums for the synthesis of metal nanoparticles. Okay, so let us. The structure looks complicated, but out of all this complication, it is only these things which are responsible for the synthesis of metal nanoparticles and their stabilization. Generally, people use these kind of materials like sodium borohydrate, hydrazine, which are toxic and harsh conditions, like greater than 120 degrees and put in pressure, temperatures, and so on, which are generally used at higher temperatures and toxic to nature. But this commonly available material, the natural gums, have these properties inherent in them. So we try to work on that. When we talk about these stabilizers, okay, these are very important. When you talk about the stabilizers, these are also known as ligands, capping agents, or passivating agents. The passivating agents, all they mean the same. So stabilizing agent, ligands, capping agents, passivating agents, all mean the same. They are all stabilizing these nanoparticles so that they don't tend to get agglomerated. Not only that, this is prevent uncontrolled, because it depends upon the concentration. We can control their size. We can prevent aggregation and so on. This growth control particle size and all these things. I will try to explain when I do my work, and all these points will be addressed there. So initially we started with silver and gold nanoparticles, which was very easy. We took precursors of gold, silver nitrate, and aurichloride, and dissolved them, put them in a solution of gamma acacia, and left at room temperature overnight. So next day when we came and we saw that there was a change in color, which itself was an indication that something has happened. And later we did all the characterization part of it, and then we tried to work on it. But at the Indian Institute of Chemical Technology, it is the organic chemistry or organic synthesis is our thrust area. Though my basics are in physics, well, I had also to work in chemistry because that is what the institute demands. And for that, when you talk about catalysis, and as all of you know, palladium and platinum are two very, very, very important metals for various organic transformations. So that is why we shifted our interest from silver, gold to palladium and platinum. So I will try to explain the results of platinum and palladium so that you can understand better. So as you can see here, initially the color of the solution looked like this at room temperature. And so initially we left it overnight, but we didn't see any difference in the color. So what we did, we thought of heating at different temperatures like 40, 60, 80, 100, and so on for about with the time, and try to work on it. But we could optimize the reaction conditions at 100 degrees centigrade for about 6 hours. So when we try to do that, this peak which you see here, is due to the palladium in its ionic form, palladium 2+. As with the time and heating temperature, by about 6 hours, this peak completely disappears, which is an indication that this palladium 2+ has got reduced to palladium 0. And we tried to do all the other characterizations like XRD and so on. And then we try to look at the solvents at different temperatures in a transmission electron microscope. And as you can see here, at different temperatures, they are all assorted. But at 100 degrees, you see that they have attained uniform size of about 8 to 10 nanometers. And all throughout the grid, there is no agglomeration kind of a thing where, all the particles are not in a big lump or so. They are nicely dispersed all throughout the grid. So this size of 8 to 10 nanometers, as you all know, palladium in this size is a very good catalyst for many of the organic transformations. So we try to work on this kind of reaction. But there is another thing which was interesting. How does concentration of gum solution influence the size of these particles? How does the concentration of gum acacia solution influence the size of these particles? We observed that at lower concentration, the size of the particle is big. And as we increase the concentration of gum acacia, they stabilize to 8 to 10 nanometers. And that is the maximum, minimum size that we could get. So when we try to understand this, the reason here is the steric hindrance on the growth of the nanoparticles is less when the concentration of gum is less, which means that it allows the particles to go bigger. But as the concentration is increased, the hindrance on the growth of the particles is also increased, and that limits the size to 8 to 10 nanometers, and which are also uniform in size. So that is how concentration also influences the particle size. So this is one point which was there in the stabilizer, where we talked about the controlled growth of the particles. So by changing the concentration of gum, you can tune the reaction parameters so that you can have particles of uniform size or uniform shape, and also you minimize the size by having appropriate concentration. So at higher concentrations, due to the hindrance on the growth, the particles are limited to their smaller size, and you can play with such kind of a thing. This was the simple reaction that we worked on, N-alkylation of hydrogenation. And all of you know that this is the conventional method of synthesis. You have your starting materials. You have an halogenating agent and a reducing agent to get this. And then you reduce it to NO2 to NH2. So you use a reducing agent. And in the presence of a base, you get your desired product. So by the end of this classical method, along with this product, you will end up getting waste in the form of these reducing agents, a halogenating agent, and a base. I'm sorry, this halogenating agent is missing here. So at the end of this reaction, you will be getting the product along with the waste in the form of reducing agents, halogenating agent, and a base. But in this technique, what we did was, we took these palladium nanoparticles in methanol at room temperature with hydrogen as an atmospheric balloon. Then these are the starting materials, and you have this materials, the desired material, without generating any waste. You could separate the reaction, the catalyst from the reaction, and we could do all sorts of things for few cycles and so on. And the important thing to understand the mechanism here is, these palladium nanoparticles are coated with gum, okay, which acts as a surfactant. So that is how they are not able to agglomerate. And when you heat and when you put a hydrogen balloon to it, these palladium and hydrogen bonds are formed, and that acts as a catalyst for these kind of reactions. So that is how this catalytic activity could be understood, and we try to work on. Then we worked on platinum, the other very important material for catalytic application. And here we were much surprised to see that these particles were 2 to 3 nanometers in identical reaction conditions. So we did not change the reaction conditions much, because nothing was happening at room temperature. Like in palladium, we heated at 100 degrees centigrade for 6 hours, and we could see the change. And we did monitor that formation of platinum nanoparticles by TEM and XRD and so on. Okay. We tried to use it in this reaction, where water was the solvent at room temperature with a hydrogen balloon. And these are some things that we could, these are various substrates we could, work on and try to get the desired products in good to efficient yields. Then I worked on core shell nanoparticles. That is, see, till now we talked about metal nanoparticles. Now we are coming to metal oxides or metal oxide nanoparticles in an engineered form. Now we are playing with these materials to have different morphologies of this material. So why core shell nanoparticles? In core shell nanoparticles, the advantage is you can have a core of one material and you can have a shell of other material and have a synergy between these two materials and have material which has properties that are completely different from the core and that are completely different from the shell. Okay, so here we are playing with two different materials and having them in one form, an engineered form, which has properties that are completely different from either the core or the shell. I will try to give some example and try to explain. And there are a lot of interesting things that can be done. And there are many different methods for the synthesis of core shell particles, like precipitation, microemulsion, reverse, all these things are there. But I have used sol-gel condensation because you can start with atomic scale and then try to tune the reaction conditions such that you can play with the size of these materials and so on. But we worked on silica nanoparticles to start with, and this method, which is there, Stauber method, which is a rugged method. If the viewers are interested, maybe you can just please make a note of this and go through this, because it's a very rugged method where you can synthesize these particles of uniform size and uniform shape between 100 to 200 or even more. So these are the starting precursors, like you have ammonium hydroxide, you have absolute ethanol, tetraethyl orthosilane, which is the silane silica precursor, and you add a few drops of water, and you stir it for about 3 to 30 hours, depending on what is it that you are looking for. You get a gel and then you try to work on it. So this is the method that is possible, and try to use it. Now, when you have this kind of metal core, and when you're talking about an oxide material or a metal as a nanoparticle, there is every possibility that the surface gets oxidized depending on the atmosphere in which it is placed. So even then, it is a core shell nanoparticle with metal as the core and oxide material surrounding it. And it is this surface which is responsible for all the catalytic activity, like it can be the oxidation or reduction reactions, or anything these kind of modifications or anything like this. So there are various possibilities of to play with these kind of materials and try to work on. It can be magnetic, catalytic, chemical, biological, and whatever. These can find applications in all these kinds of things. So I will try to explain you one example. It's a multifunctional core shell nanoparticle which has various functional properties. So this is like, I'm showing a typical example, but depending on your usage, we can use it up to whatever way we want it. Like, this core, which is here, it can be magnetic or fluorescent. If you want to see a change in the material, then you can have a fluorescent material as the shell. Or if you want to make it magnetic, the whole thing as a magnetic particle, core shell magnetic nanoparticle, then you can, if you have the core as a magnetic, the whole thing becomes magnetic, and so you can use it as for various magnetic applications. So depending on that, so you can have inorganic material as shell, one which can be silica or whatever, titanium, whatever, whichever is of your interest. Then you can functionalize it. I will try to explain about this functionalization, where the people have used these kind of functional groups to functionalize the surface, and you can have whatever kinds of stabilizers or target moieties and whatever, and make it a complex multifunctional core shell nanoparticle. So that is basically an idea, and that is how we try to work on. So these are some things for surface modification. I will explain, like thiols, amines, phosphines are the ones which are used for surface modification of metal nanoparticles. If they are oxides, metal oxides, you have these oxygen terminals or OH terminals on the surface. I will try to explain that, to which you can have these kind of monomers attached as functionalizing groups. So these are some modifiers, like 3-amino-propyl trimethoxysilane. When by using these as your modifiers, you will have surface terminated with amine group. Similarly, if you want surface terminated with thiols, you can use this kind of 3-mercaptopropyl trimethoxysilane. So in this case, what happens is thiols will be your functional groups that are there on the surface. So if you are diphenyl phosphine, if you want to have as your terminating agent. So depending on what you have done, you can do that. But once you have synthesized these materials, now you have to characterize them. For that, people normally use FTIR because, once you have these functional groups, so the functional groups that are there on the modifiers can be easily detected by FTIR. And you can say that, yeah, this surface is modified with this kind of material. This material has these functional groups which are identified by FTIR. So like that we can talk about. So, but we try to work on those kind of things and try to understand. And these core shell nanoparticles, depending on the material, kind of material that is there, they have different forms. Like, if you have a semiconductor, core shell nano, semiconductor kind of a material. So semiconductor, metal polymer, metal oxides, or metal whatever, or metal semiconductor. So depending on the type of material that you use for your kind of applications, you have various core shell nanoparticles. And as you can see in this example, initially you can see the core. But once you start to coat the shell layer after layer, you can see only the shell here, but not the core after a few coatings with this material. So, and by depending on the thickness, we can also measure the thickness by UV spectrometer and then try to understand that. There are various varieties of core shell, like, it's a hollow particle, core shell kind of a thing, encapsulated hollow particles of material, the core shell kind of a thing. And depending on how these shell materials are, coated onto the surface with functionalizing groups, they are different types. Now let us try to understand, take an optical example and try to understand here. In this example, this is the ionic form of gold, and you see increase in the intensity of the material. The only reason here, they are all red wine in color, but only thing is things are becoming darker as we go by. And this increase is because of the increase in concentration. Okay, as the concentration is increased, you see increase in the intensity of the material. And the whole material is only gold. Initially, it is gold ions, but here they are all gold nanoparticles. And that is one example here, a gold nanoparticle, red wine in color. And when this gold nanoparticle is coated with silver, okay, when it's coated with silver, you see the change in color. It's completely contrast. It's not neither red wine in color or the color of silver. It is yellow in color, which is completely different. And here again, it is coated with gold. You see blue, which is still more different. And then again coated with silver, and then it's coming back to its, red wine color. So which means that something is happening, some synergy kind of a thing, is happening. Where we are. This is how we try to start to believe that core shell nanoparticles are having properties which are different from their either core or the shell, and there is something different. And this synergy between this core and shell material is what is making these proper materials so interesting for understanding and usage. Okay, this is the same thing. Depending on the thickness of the shell, you can see a shift in the UV surface resonance plasmon peak, which gives us an idea about the thickness of the shell material. In this case, it was silica coated with gold. If it is about 5 nanometers, it is about, like about 1050 nanometers wavelength. But as the thickness is increased, you see that it has come down to about 750 or 750 nanometers, like that. So depending on the thickness also, you see a shift in the surface resonance plasmon peak, and that gives us an idea about the thickness of the shell. So I will give you some examples here. Initially, we started with silica nanoparticles, and this was the reaction that we worked on. And what is important here is, this reaction was done with earlier also, but using harsh conditions. But in this case, what we did is, we tried to work on at room temperature and with water as the solvent. That is our interest. So that is how we are trying to adopt the principles of green chemistry. So that is why this gave us a lot of interest. But there is something different here. So what is this major thing which is very important? These nanoparticles have large surface area, which makes them attractive for catalytic applications. So what we did in 2 different protocols. You can see a difference here of only ammonium hydroxide 4 units, ammonium hydroxide 8 units. With this small difference, you can synthesize these the materials in 2 different sizes. This is 60 to 70 nanometers and 350 nanometers, with only small difference in ammonium hydroxide. Okay, and when you look at the surface area, these particles, which are 60 to 70 nanometers, have a particle size of about 240 meters square per gram, whereas this 350 nanometers has about 20 meters square per gram, which is almost 10 times less. So the surface area, which is responsible for catalytic activity, is much more in these particles, 60 to 70 nanometers. So obviously, these particles are better catalysts compared to this size of particles, is about 350 nanometers, which has surface area of about 20 meters square per gram. So that was also one of the an observation that we tried to present in this work. Then we tried to work on core shell nanoparticles. With the interest in the silica nanoparticles, we tried to work on two different core shell nanoparticles. One was copper, and we worked on this reaction. So silica copper core shell nanoparticles. And here we worked on the tungsten as the shell material. And here again, you will see that these reactions are done at water using room temperature, and here again, water and room temperature. Of course, H2O2 is the hydrogen source which is there. Now, how do we look at this? I'm talking about the functionalizing property here. If we don't functionalize, the problem is this, this core material and the shell material which is there, they don't have a bond between them. I call it the friendly relationship between the core and the shell material. Okay, a friendly relationship between the core and the shell material. When this bonding is not there, when you use such material for catalytic applications, there is every possibility that the catalyst which is there around it can leach in the reaction, and then by the end of the reaction, you will have only the shell core material, and all the shell material has reached into the reaction mixture. So what we try to do here is we have to functionalize it, and by modification. And when we look at the silica nanoparticles, it is these OH terminals which are there normally, and they do not allow these metal nanoparticles to sit on them. So in order to build a surface friendly relationship, people use, like as I said, surface modifying agents like 3-amino-propyl triethoxysilane. And when you use this as a modifier, you see that these OH group terminals are now NH2 terminals. Then you can have these metals and metal ions on it, and then you can reduce them and have these metal nanoparticles on these kind of shell material on the core of silica. So that is how we try to work on, and we synthesize these materials. We try to characterize it by various techniques like TEM, AFM and all. Most of the times, what is very important when we talk about this characterization is that they should be, when you do the analysis by two or more techniques, the results should be correlating. They should be correlating, and the size should be uniform. Like for example, here we talk about this TEM analysis. It is about 55 to 60 nanometers. This is by atomic force microscope. Here again, you see that the sizes are between 50 to 55 nanometers, and the shapes are something like this. And this is one example. You have the silica particle on which these are copper nanoparticles which are there on the shell material, and these copper nanoparticles are of the size of about 2 nanometers. So this is about silica copper. See, these are very dear to me. I've done all this characterization myself, and I can explain each one of them separately also, but still when they have come here, so I try to take it an opportunity to explain. XRD, as you all know, X-ray diffraction is one very important thing, because that gives us an idea about the synthesized material. What is the material that is there in the sample? So once, in this case, it can be silica and also copper. So we have to see that. So once we have done with that, then we did what is called TGA coupled to mass. All of you know thermogravimetric analysis. Thermo meaning temperature, gravimetric something to do with mass or weight, and analysis. So in TGA, thermogravimetric analysis, sample is subjected to heat with respect to time or temperature. Okay, so when you do that, you see some weight loss. A decomposition is there, which is due to the decomposition of the material and their various parts. So in this case, what happens is, this initially you see a peak here, a weight loss, followed by a gradual weight loss, but to about 600 degrees centigrade. So this initial weight loss is due to the solvents that are there. It is the solvents in this case was water, so it is dehydration. If it is any organic solvent, it is desolvation. So depending on whatever is the medium in which these particles are dispersed, you have different solvents. So initial weight loss is due to the solvents or the material in which it was dispersed. So dehydration or desolvation, then a gradual weight loss. But generally what happens is small weight loss features are not seen in a thermogravimetric analysis. So what people do is they take a derivative of it. So when they take a derivative, things become very clear. And this initial step, first step is very clear. But other than that, you see small step, which is around 300 or 400 degrees centigrade. So this small step is due to the decomposition of the functionalized material, which is there between the core and the shell. So all these fragments which are there, these could be analyzed by coupling the TGA to a mass. So when this TGA was coupled to mass, whatever fragments that are getting decomposed due to the functionalizing agent, we could observe, and then it gave us a confirmation that the material that we have synthesized has these functionalizing agent between the shell and the core. Okay, so that is how we try to confirm. Then we talk about copper. We told in my earlier slide, I told you that copper ions were reduced to copper metal. So this is this X-ray XPS, X-ray photoelectron spectroscopy, as I have already told in the beginning. So X-ray is XPS gives us information about the elements and their oxidation state. So initially, this peak, which is there at 932.4 electron volts, is due to copper in its metallic form. And this was the starting catalyst. But after a few reactions, we observed that there are two peaks. The catalyst was analyzed, the reused catalyst was analyzed, and you see that along with this copper in metallic form, there is another peak, which is due to copper 2+, which means some of the copper nanoparticles have got changed to copper 2+, and that is the reason you see these two peaks, which are due to copper, and this is due to copper 2+. So like that, we can know about the element and its oxidation state by XPS. Okay, then what we did was we tried to look at synthesis of hollow particles of iron oxide, because iron oxide, as you all know, is a very interesting material for drug delivery and other things. So we wanted to make hollow particles of this and try to work on. So the precursors are the same. You have the silica core, functionalize it, then you have iron chloride as the what is called the source, the precursor for iron oxide. Then you have core shell particles of iron oxychloride. You synthesize, calcine at about 100 degrees. Then you have iron oxide here. Then you nicely remove this, selectively remove the silica core. Then you have hollow particles of iron oxide. We tried to measure at different steps of this reaction. And as you can see here, initially you don't see the core. Okay, but at the end of the reaction, you see that the core is completely removed and you have only the shell material. Okay, this was at after calcining at 1,000 degrees, and also removing treating with HF. So you have removed silica also, so you can very clearly see that they are hollow particles of iron oxides. Then I worked on polyaniline. I'll try to finish as early as possible, but anyway, let us see this. This is also very interesting, because here what I'm trying to come to is I started with metal nanoparticles. Then I told about core shell nanoparticles, and here we are talking about polyaniline. All of you know it's a conducting polymer. And these three people, Professor Shirakawa, McDermott, and Hager, these are the people who got the Nobel Prize for the discovery of conducting polymers. And people have used it as a catalyst support with various active species like palladium, osmium, and so on, for their catalytic applications. We ourselves have used this palladium and osmium, and we try to work on these kind of reactions. But we wanted to do something different. And the difference is that we wanted to synthesize them in different forms. And for that, you have this aniline and sodium hydroxide as the precursor. And if you change their ratios, okay, if you change the ratios and keep the synthetic protocol the same, you end up these materials as spheres, rods, and tubes. When I show you the next slide, it becomes very clear here. This scanning electron microscope images of spheres, rods, and tubes. And these are the TEM images of spheres, rods, and tubes. In these tubes, you can very clearly see the contrast is hollow. And this is hollow because you see a contrast difference here, and they are open-ended. And these are few microns in length. Only the thing is this the internal diameter of the tube is less than 100 nanometers. So that is how we try to synthesize polyaniline in different forms. Then how do they make a difference? We will try to understand that. We try to measure their TEM images at regular intervals. So at 1 hour, you see that small dots are forming, which by about 6 hours, they tend to self-assemble into that kind of a form. By about 12 hours, a rod kind of morphology is slowly becoming to appear. But by 24 hours, you see that they are perfect rods. And the color of the solution is also changed from almost colorless to dark green color, which is the color of polyaniline. So this polymerization is complete, and this you see they are perfectly rods. So we try to do all of them, and then we looked at the surface area for catalytic applications, and these spheres were about 17, rods about 37, and tubes about 42 meters per gram. So obviously here only you can tell that this have to be necessarily good catalyst support, and that is what we wanted to prove, and we try to work on these kind of reactions, and we could see that these tubes were better catalysts and they for conversion or selectivity, and we try to work on this kind of materials. Then came magnetic nanoparticles, and viewers who are interested to know about these magnetic particles, their synthesis, protection, functionalization, and applications, please go through this, Angiochemy International edition 2007. This article gives a clear idea about the various applications or various synthetic protocols or various how you can protect, how to functionalize them and all. It gives us a very clear idea, and it's a very wonderful paper. So I request all of you to go through this. And the advantage of using these catalytic material for as catalyst is that the separation from the reaction mixture generally becomes very easy by just placing a magnet next to it. These particles, as I said, they are very small. So when you have to separate them from the reaction mixture, you have to centrifuge these particles using a very high revolving centrifuge, which is expensive, and in the process you lose some of these materials. But when you look at this magnetic material, separation from the reaction mixture becomes very easy by just placing a magnet next to it. Okay, so that is why we started working on magnetic nanoparticles. And as you can see here, they are in two different solvents. By just placing a magnet, you can separate them from the reaction mixture. And this is the silica sphere on which these iron oxide nanoparticles are coated. Some people coat it on the surface, some coat it, encapsulate iron particles into the silica spheres. Depending on whatever way you want to, you can synthesize such kind of morphologies and do it. And this was the first reaction we worked on, the three-component coupling for the synthesis of propargylamines. And then starting that, we did all sorts of things and tried to work on this kind of iron oxide nanoparticles. But we wanted to do something different here also. These are the TEM images. They were about 25 nanometers in size before and after catalytic reactions. And these are the XRD images that you can see are okay. Then here comes that XPS spectrum again. XPS, I will repeat again, it gives us information about the elements and their oxidation state in this example. So as you all know, Fe3O4. So it has iron in two oxidation forms, iron 2+ and iron 3+. And iron 3+, some 50% of them, it is in tetrahedral coordination. Fe2+ and Fe3+ are also there in equal amounts in octahedral coordination, and they keep hopping between the two. We cannot talk anything about the coordinations or tetrahedral or octahedral coordination, but we can talk about the oxidation state. And XPS is one of the few techniques that gives us information about their oxidation states, presence in their multi-oxidation states, other than like, Mossad or things like that. But this is very clear, like, this peak, which you see is due to Fe2+, and this peak is due to Fe3+. Viewers who have listened to my earlier talk on XPS, I am sure you must have seen this slide also there, but it is very, and you would have understood it better here now. So the presence of iron in two oxidation states, Fe2+ and Fe3+, can be identified by this technique. And then later what we did, we worked on copper ferrite. When we are talking about copper ferrite, the advantage here in iron oxide, the active species is iron in either 2+ or 3+ form. But when we have added copper to ferrite, it means that we are having another active species, that is copper, in its either valence state or in its metallic form. So like that, we are having two elements in the material which are active species for this kind of reactions. So we initially started with synthesis of triazoles, then tetrazoles, and then these kind of reactions. And here, what is interesting to understand is the mechanism. So when you, the same reaction we did with iron oxide and followed it with copper ferrite, and we found that copper ferrite as catalyst was giving better yields compared to iron oxide, which itself means that there is a synergy. That is what I call synergetic effect of copper and iron metal centers for accelerating the improved synthesis of amides in this reaction. So that synergy between copper and iron is what is making the difference. And when we try to look at this mechanism, which is all known, but what is interesting is where exactly copper acts as a catalyst and where exactly iron as a catalyst to regenerate this copper catalytic center. So that is where we have to try to understand. And when we try to put this mechanism, in this mechanism, it clearly sees that it is copper 2+ which gets converted to copper 1+ here, which converts back to copper 2+, that is the regeneration, because of the iron which is there in its multi-oxidation states, iron 2+ or 3+. So that is how there is a synergy between these two, and that is what is making a difference. Next, I talk about this small thing, the design and synthesis of these molecules. Hope I am having a few more minutes. Ashish? Ashish?
Yeah, you can continue, sir. Please.
Okay. I continue. So there are synthesis of these molecules: nitrovinyl stilbenes, nitrovinyl biphenyls, biaryl stilbenes, and biaryl ethylenes. So the starting precursor is this one, which are 3 methoxy groups, which are there as you can see here. So these 3 methoxy groups are there, and this benzene ring and all. So this part is the common thing for all of that. But there are few pharmacores which are there, which have come from various other things. So let us look at the basic idea and how we got this idea. So initially, if you look at resveratrol, all of you know it's a known molecule, and it has been used for cardio protection, anti-inflammatory, anti-aging, and anti-cancer agent. And these basically you see a pharmacore here with two hydroxyl groups and so on. In this is calcicine, which is again this benzene ring with 3 methoxy groups is the pharmacore, and this is also very well known. And this main activity of this molecule is because of these 3 methoxy groups. And there is another molecule which is beta nitrostyrene, and this is the pharmacore which we looked at. And taking these 3 basic pharmacores, taking one minute, yeah. Taking these 3 pharmacores, we try to work on. Like, these are the 3 different molecules. Okay, these are the various molecules and the various steps that were involved for the synthesis of these molecules. And as I said, this is the starting material, bromination, coupling, and all sorts of couplings. But finally, we end up getting these molecules. We worked on this for various cancer cell lines, and then did all sorts of modeling and all. For that, I request you to please look at these papers for better idea and try to understand. Next, these days we are working on this. I'm coming to the end of my talk. These days we are working on hydrogen production and CO reduction to methanol. And these are the 2 schematics that are being followed. For hydrogen production, we have developed photocatalysts in different morphologies and then try to use on. This is the synthetic lamp. It's a xenon lamp at 300 watts for solar source. And we are trying to work on. And CO2 reduction to methanol also we are doing, and this is what we are working on. So this is what one example I will show you, which is alpha Fe2O3, which is on, this is metal organic frameworks of titania. And we have tried to work on this. And what is important, as you all know, these are the basic mechanism which is there. You have the valence band and the condension band. And these are what are the various steps that are important. First thing is by the absorption of light radiation, you have to generate electron hole pairs. So you have the electrons here, you have the holes here, you have to generate these things. But the recombination time should be reasonable so that other activities can take place. For that, what you do is this separation of this excited charge is very important. Then this transfer of the electrons and holes to this surface of the photocatalyst, followed by recombination, and then utilization of the charge on this surface of redox reaction for the catalytic activity. So these kind of steps are followed when we talk about that. So we are trying to work on that. For that, and as I said, it is iron oxide with titania as a metal oxygen framework. So initially we had to prepare Fe3O4 capsules. As you can see here, these are the steps that we followed. This is SDS, Fe3 iron chloride as the precursor, and all these steps we followed for the synthesis of these, followed by the synthesis of these kind of titania as metal organic formworks. So we got this kind of things, and then we try to work on that by TEM. So this is the way we look at, and this is all the chemical composition, chemical distribution on that this kind of material. You can see that most of it is titania and oxygen. And though it's not very clear here, but iron is also distributed all throughout, but for this area where the concentration is little more. So that is where we see this kind of dark green kind of iron oxide material in that particular place. So like that, we can see the chemical distribution and try to understand. And we draw a line across this point and then try to look at the line scan at this elemental line scan at this point, where you can very clearly see that it is mostly titanium oxygen, and also this iron is also very much present in this particular area. Okay, so that is what we are doing, and what is my interest. But I will try to explain you some of the techniques that I have been using at IICT, and these are the thermal analysis techniques. This is the differential scanning calorimetry with the TA systems instrument, which can run from -90 to 725 degrees centigrade. The conditions that are necessary to understand before we start the analysis is the heating range, that is from what temperature to what temperature we have to heat. Then the heating rate, that is like, depending on the heating rate, there is a difference in the thermogram. So the heating rate is another very important thing. Then the next important thing is the atmosphere in which this has to be done. So is it reducing atmosphere, oxidizing atmosphere, or an inert atmosphere? So depending on that, the reactions happen also, and so we get the differential scanning calorimetry. So what is the differential scanning calorimetry? You have sample and reference. Both are subjected to identical temperatures. But depending on the sample, it can be an endothermic event or an exothermic event. For example, if you have ice, how does it melt? It takes in heat and it melts, changes its form from solid to liquid. So that is an endothermic event. On the other hand, liquid gets changed to solid by the reverse process where it gives out heat and changes its form. So like that, endothermic and exothermic events are measured in differential scanning calorimetry. I talked about thermogravimetric analysis, and this is the mass spectrometer which is attached to it. So whatever evolved gases that are coming here due to the decomposition of the sample, these gases are measured in the mass, and we try to get the idea about the decomposition material. So this is the instrument that we have, TGA instrument coupled to mass, and this instrument can be run from 25 to 1500 degrees centigrade, where again, these are the conditions which are needed. Well, sir talked about particle size analysis. We have this Master Sizer 2000, a dynamic light scattering instrument, which has both wet and dry mode. This is the dry mode where we take the dry sample as such, and this is the wet mode where you have the sample dispersed in the appropriate solvents, and then we try to measure on. So like sir has explained in detail, so I don't want to talk about here. So depending on whatever is the size, in this instrument, we can measure the sample size from 20 nanometers to about 2000 microns. So this is the limitation here, because as sir was telling, me theory is something which has to be followed when we talk about particles of lesser dimension. So in this, it is laser diffraction. So the limitation is that the particles less than about 100 nanometers are difficult to analyze in this instrument. And this is the newly added X-ray fluorescence, which is the energy dispersive X-ray fluorescence instrument. This is again a desktop kind of a thing, which can be used for measuring the elements present in the sample, either in its elemental form or in oxide form. So this is another thing which we have. And this is the transmission electron microscope, and all the images that I have shown in the talk are all done on this instrument. This is the transmission electron microscope, and this is a new one which has come. This is 120 kV. This is a 200 kV instrument with all kinds of mapping and all sorts of things attached to it. So this is a new addition to our system. And this is the XPS, X-ray photoelectron spectroscopy instrument, which I talked about. And one thing I want to bring to the notice of all of you, all the analytical facilities in all the CSIR labs in India are now available for general use. I repeat, all the analytical facilities in all the CSIR labs are now available for analytical services. And if you look at this site, www.analyticcsir.in, you can access any of the instruments in all the research CSIR labs in India. And depending on your necessity or utility and your comfort, you can go to the appropriate lab in the software, book a slot, or you can contact them and try to book a slot for yourself and try to work on. So all these facilities are now available. Only thing is they are chargeable, and depending on your position, like students have concession, industry has their own rates, but they are all available for general use. So I'm sure many of you will be having wonderful ideas, but because of the limitation of these kind of facilities, may be hesitant to start doing research. But I wish that you can take a small step and try to come out and use these facilities. And I'm sure all of you would be doing wonderful research in whatever area is of your interest. So these are some of the students who have done my work. And whatever I have presented is all because of my students. And all the credit, maybe 99.99% credit, goes to my students. And these are the two instruments I have talked about, TEM and XPS. And I consider them to be my two eyes in the institute, because with these two instruments, I have seen the beautiful world of nanoscience and nanotechnology. So I consider them to be my two eyes in the institute. Well, as earlier also, I generally end my talk with this slide, not because I'm anything like, well, she is great, no doubt, but nanotechnology, as I already told, it's a multidisciplinary area where branches of all sciences have to work together and do something beautiful to mankind. So these few lines, when I happened to go to Missionaries of Charity at Kolkata, these lines caught my attention. What I can do, you cannot. What you can do, I cannot. But together we can do something beautiful for God. Well, it's a wonderful statement, because all of us are born unique, and all of us are born with unique capabilities. So what is more important is we have to work in team, have faith in team members, and then try to work out and come out with something beautiful to mankind. As in the present situation, like COVID situation, also we are seeing that people are working in teams all 24/7 to bring out a good medicine or a good vaccine. So that only makes a difference. So I'm sure all of you should work together with whatever ideas you have, come out with your discussions, and then try to work out for the good of mankind. Thank you very much once again for giving me this wonderful opportunity. Thank you all.
Sir, thank you so much, sir, for giving a very nice talk. Now I would like to request for chairpersons of the session, Professor K.D. Verma, Head Department Physics, Srivastava College, Aligarh. Please, sir, over to you. Unmute yourself, sir. Unmute yourself.
Yeah, I'm done.
I am audible.
Hello.
May I audible?
You are audible, sir. You are audible.
Thanks to the speaker
for nice presentation and nice talk.
Hello?
On yes. Am I not audible?
Yeah, you are audible,
Hello?
sir. You can continue and summarize the talk, please.
Hello?
Okay. Yeah.
Hello?
I would like to thank speaker, Dr. Sridhar. Nice talk on nano engineered materials, synthesis, characterization, and catalytic applications. First of all, he delivered a talk or introduced us on photoelectron microscopy, and he told us about the photoelectron microscopy that it gives us information about the elements present in
Hello,
the
am I
sample
audible?
and oxidation states, all the elements in the multi-valency
I am
states.
not
Depending on the
hearing
neighboring
anything.
elements, we can find oxidation states and molecular environment. And he
Hello?
also talked about the nanoscience. That is, the nanoscience is not new, but it is a very earlier we know about this. But in nanoscience, the properties
Sridhar, sir,
differ
you are audible.
significantly
Please, you are audible, but unmute yourself,
from
please.
those at in a nanoscience, the properties differ significantly from those at the micro molecular size.
Ashish,
That is, size of the particle
actually, I am
is
not able
1
to
nanometer to
hear
the 100
anything from your
nanometer.
side. Am I audible there?
Yes, sir. You are audible, sir.
Sir, you are
But
audible.
the thing is, right now, I am not able to listen anybody talking to me from that side.
You can connect again, sir. Sridhar, sir.
Right.
We can develop materials by controlling shape and size at the nanometer scale. And he also discussed about the physico-chemical influence on the interface between the nanomaterials and other systems.
Sorry,
Size.
Sorry. Can you please repeat the question? Just now I got the audio.
Sir, there is no question. Please, sir, there is no question. Sridhar, sir, there is no question. Your talk is summarized by Professor K.D. Verma, head of the department, Srivastava College, Aligarh. Yeah, please, sir, please.
Yes.
Stay tuned, please,
Size,
sir.
shape, and surface area, surface charge, energy, roughness, and porosity, valence, and conduction states, functional groups, lesions, crystallinity, and defects, hydrophobicity, and hydrophilicity. This was discussed. The invention of new advanced analytical technique makes it different from the earlier, because nanotechnology is not new, but only the analytical techniques makes it different from the earlier that is microscopy. Its challenges is to synthesize material of the identical size dependent properties with the size color of the material changes. Synthesis and characterization applications were also discussed. Here he also discussed about the stabilizers, roles of stabilizers. Stabilizers prevent uncontrolled growth of the particle. They also prevent the particle aggregation, control growth rate, controls particle size, allow particle solubility, and he also discussed about the gum acacia as a facial reducing and templating agent for palladium nanoparticles. He also discussed about the TEM images of PD nanoparticles, and he discussed that particles can be prepared using PD precursor and gum acacia. Core cell, he also discussed about the core cell nanoparticles by different techniques, that is the precipitation technique, sol gel condensation techniques, and others. And he also talked about this that he is using this sol gel condensation technique. Nanoparticle synthesis of silica nanoparticles were also discussed by Stober method, and the size of the particle were 10 to 20 nanometer size. Dr. Sridhar also discussed about the cell protection and functional properties, that is the multifunctional core cell nanoparticles. Type of core cell nanoparticles were also discussed: semiconductor, metal, semiconductor, and others. Tailoring of the optical properties of the gold colloids were also discussed, and he also discussed about the color change of the particles by using different precursors. Synthesis of various size and surface area of silica nanoparticles were discussed for the catalytic properties. Characterization techniques: TEM, AFM, UV, visible absorption spectrum, TGA, XPS, and other techniques were also discussed. He also discussed about the hollow particles of iron oxide, and he told how can we obtain the hollow particles by removing the core. He also discussed about the Pani nanoparticles and some characterization techniques for Pani nanoparticles. Thanks to Professor Dr. V. Sridhar for the nice talk. I would also like to thank our chief guest, Professor A.K. Mittal sir, the Vice Chancellor of Dr. V.R. Ambedkar University, and Pattern in Chief, Professor Bhuvnesh Gupta, Department of Textile and Fiber Engineering, IIT Delhi, Professor Durgesh Pant, Director, USARC, Dehradun, Department of Science and Technology, Government of Uttarakhand, Dr. Pankaj Varsne, Principal, Varsne College, Aligarh, C. Atul Kumar Gupta, Secretary, Management Committee, Sri Varsne College, Aligarh, Professor K.K. Pandey, Principal, SVS, Government PG College, Rudrapur, Deputy Director, Higher Education, Uttarakhand, Professor Chandra Ram, Principal, RH Government PG College, Kasipur, Professor R.C. Purohit, Principal, HNV Government College, Khatima, Dr. V.D. Upadhyay, Principal, Dharam Jyoti Degree College, Aligarh, Dr. Neerja Sharma, Head Department of Chemistry, SB College, Dr. M.C. Varsne, Chief Proctor, SB College, Dr. Ashish Kumar, Assistant Professor, Department of Chemistry, HNV Government PG College, Khatima, Uttarakhand, and Dr. Shiv Kumar Upadhyay, Convener of the conference, Faculty Coordinator, Alumni Affairs and Development Program, Sri Varsne College, Aligarh, and all the participants. Thanks to all.
Thank you, sir, for a very nice summary given by our keynote speaker, Dr. V. Sridhar from CSIR IICT Hyderabad. Sir, thank you so much. Thanks a lot, sir. So now, before conclude the today's session, I would summarize today's. So I will take only 10 to 12 minutes to close the today's session and the today's session. So please, before conclude, there is one quote like COVID-19 has stopped the life movement, but not the learning. The ongoing RAAT 2020, the main focus of conference is to provide recent fundamentals, understanding and technological advancement in the era of analytical techniques like STEM, XRD, TEM, HPLC, FTIR, DSC, XPS, and TGA and particle size analyzer, etc. With the renowned scientists from different esteemed institutions across the nation, more than 25 research institutions, more than I'm audible, Dr. Assis?
You are audible, sir. Please continue.
Yeah, thank you so much. More than 25 research institutions are contributing in this conference, and this will be an opportunity to gain the depth knowledge about the topic from our scientific panel. we are envisaging the huge success of the event. So, on the behalf of RAAT 2020 team, I want to conclude the session for today's proceedings. I am very thankful to all the dignitaries, delegates, and participants who remain attached patiently with us. We are very thankful to our chief guest for today's conference. As a chief guest, Professor Ashok Kumar Mittal, as a Vice Chancellor University Agra, to give his valuable time and grace this auspicious occasion. We are thankful for the presence of our patron-in-chief, Professor Bhuvnesh Gupta from IIT Delhi, and Professor Durgesh Pant, Director Users DST Uttarakhand, for their inspiring direction to the delegates. We are also thankful our patrons and honorary chairs, co-chairs, and all the invitees for their addresses to the delegates, which will open a new pathway to the conference organization. We are thankful, highly thankful to our delegates and guests from different parts of the country for their participation in this conference. We wish that this event offers a highly interactive platform for our delegates. We express sincere thanks to our today's plenary and keynote speakers, Professor Mukesh Kumar Singh, Director UPTTI Kanpur, Government of Uttar Pradesh, and Dr. B. Sridhar, Senior Principal Scientist at CSIR IICT Hyderabad, for their knowledgeable talk about the various new techniques like particle size analyzer and other techniques in nanoscience and technology, respectively. We hope all of you get some newer ideas and very clear about some of the recent techniques used in different fields. We are also thankful to our chairpersons, Professor Vivek Kumar from IIT Delhi and Professor Chitra Pandey from Nainital, from Professor Bhanu Nandan from IIT Delhi, and Dr. K.D. Verma, Head of the Department Chemistry, gracing us with their presence and giving their valuable time. We are highly regretted for some of the technical glitches occurred during the sessions. We hope you all will understand some of the limitations of e-platform. Inconvenience is highly. I am sure today's session were going to be highly informative in terms of science and technology, different materials, and we look forward to a very creative interaction with all the delegates tomorrow as well. So meet all of you tomorrow with the same enthusiasm and with some more brainstorming sessions from the various eminent speakers. Till then, stay home, stay safe, meet all you by tomorrow. Thank you so much. Thank you everyone for your presence.
Okay, thank you all the organizers. Thank you for giving me this opportunity.
Yeah. Thank you, sir. Thank you, sir. Please. We will meet at the same time for tomorrow, 10 to 2 o'clock, 10 a.m. to 2 p.m.
Sir.